Choosing a programming language to start with is the first step in learning to code, whether you want to do it for a new career, as a side hobby, or simply to improve your current position that you're working in. One go-to programming language commonly used by all the developers across the world is C++. Hello everyone, I hope you're doing good and staying safe. I welcome you all to yet another training series by SimpliCode. I hope my audio is fine and the screen is clearly visible. If you guys are facing any issue, do let us know in the comment section below and we'll try to resolve as soon as possible. In today's session, we will be taking you through C++ programming language. C++ is one of the most well-known and well-used programming languages today, used by more than 4 million programmers worldwide. The language made its debut in the late 20th century as an iteration of the C programming language, which began as an extension of C but evolved into a different language with its distinctive characteristics and features. So it is important to learn this general purpose programming and coding language, which is used in developing browsers, operating systems, applications, as well as in-game programming, software engineering, data structure, concepts, etc. if you are from a computer science background. So in this session, we will explore the history of C++, its uses and features, some important concepts like arrays, loops, switch statements, strings, pointers, and other object-oriented programming concepts with hands-on example. But before we get started, if you're new to the channel and haven't subscribed already, consider getting subscribed to our channel SimpliCode to stay updated with all the latest tech content. And hit that bell icon to never miss an update from us. So without any further ado, let's get started. Firstly, let us discuss the agenda for today's session. We'll start this tutorial with a quick introduction to C++, and then we'll understand what exactly is C++, is its history, why we use it, and how it works. And then we'll download and install C++ using VS Code. After that, we'll be going through some basic important concepts like C++ strings, if-else statements, and then we'll install dev C++ on your Windows system. After that, we will be covering some again important concepts like loops in C++, C++ functions, and then we'll understand what is called by reference and called by value in C++. Up next, we'll understand what is recursion in C++, how it works, and then we'll discuss some of the most important recursive functions used in C++. After that, we'll understand what are C++ header files. And up next, we will cover what are arrays in C++, types using certain examples as well. And finally, we'll wrap up the session by understanding what are pointers in C++. I hope I made myself clear with the agenda, guys. So without any further delay, let us dive straight into today's session. Over to our training expert.
So let's start with the introduction to C++ programming. C++ is a popular programming language introduced by Bjarne Stroustrup in the year 1979. The aim was to make a dynamic language that is efficient and has some additional features to C. Initially, it was called C with classes as it was an extension to C language, but later renamed as C++. It is general purpose case sensitive language and it is called pre-compiled language because it converts the source code directly to the machine understandable code. It is an intermediate level language because it contains both features of high level and low level language. C++ supports the features of object-oriented language like encapsulation, inheritance, polymorphism, etc. It also supports procedural programming and functional programming as well. Welcome to this video where we'll be telling you how you can install C++ on VS Code and Dev C++. After we are done with the installation, we'll also learn how to run a program on both of these code editors. So we'll start with Visual Studio Code. To download VS Code, let's go to Google and search for Visual Studio Code or VS Code. We'll click on this first link. This is the official web page for downloading the Visual Studio Code. And we'll now click on this download for Windows blue button. And now we'll click on download now. Here it is getting download, and as you can see, thanks for downloading Visual Studio Code for Windows. Once we are done with the download, we can click on this open folder. Here it is. Now we need to install this file, so we'll double click on this file. And this is the setup wizard. We'll click on this I accept the agreement. And we'll click on next. As we have accepted the license agreement, now we can select our destination folder or we can leave it as it is. But make sure there must be 293.2 MB of free space on that particular disk space. Now we'll click on next. Here we can again click on next. There is no need to change over here. And now you can click on this create a desktop icon button or anyone else as per your choice. Now we'll click on next. And now we'll click finally on install. It is getting installed. It will take some time. Now we can click on this finish button. Launch Visual Studio, we have marked it. It is already marked. So when we click on this finish button, it will launch the Visual Studio Code. So as we can see, this is the Visual Studio Code. So as we have installed VS Code, now we have to configure it so that the C++ programs can run in this code editor. So in order to do that, we need to add some extensions. So we'll click on this extensions button. Now here we will write code runner extension. We'll write code runner. And this is the extension. We'll click on this install. And it is getting installed. Here are some instructions. We can click on Ctrl plus Alt plus N or press F1 and then select type run code, but we'll deal with that later. Now we'll add another extension, that is C/C++. Here it is. We'll click on this install. Here we can see downloading Visual Studio Windows Debugger. It is getting installed and I think it is installed now. So as we have added both the extensions, we can define strings as a collection or group of characters. It is basically used to represent text in the program, and we can perform many operations on strings in order to manipulate it. The syntax of string contains a collection of characters surrounded by double quotes. For example, here string is the type, str is the name of the string, and coffee is the value that is assigned to the string. In C++, there are two ways to create a string. First is C-style strings. In C-style strings, collection of characters are stored in the form of arrays. They are basically arrays of type character. The second way is using string objects. We can create string object to hold a string. They are implemented in the standard library, which we must include in the program using #include. So here we will do an example of string and we'll do some push back and pop back operation on it. So first of all, we'll include the header file #include iostream. Then using namespace standard, Okay, now we'll start with int main. Alright, first of all, we'll write string data type, then the name of the string s. Here s is the name of the string. Alright, now first of all, we'll display a message to enter a string. So Okay, enter a string. Now get line. This is the syntax when you want to take the input of a string. So get line, cin is used to take the input, and s is the name of the string. So this is how we take the input, and now we will print another message saying that you have entered Now here we will print the string s. Next line and L. Okay, now we'll do some operations like s dot pushback. This will add an element at the end of the string. So let's say we want to add y. So we'll write y inside the bracket, s dot pushback, and inside the bracket with single quotes we'll add y. Now we'll display a message saying after using pushback function, we'll print the string. That is, after using the function pushback, the string would look like this. And now we'll use another function s dot popback. It will delete the element from the end. So we'll write cout and we'll display the message after using popback function. Let's write popback only, and we'll print the string. Okay, now after that we'll write return 0, and I think it's done, only the spelling is wrong over here. Okay, yeah, now let's try to run this. As we can see the message, enter a string. So let's say I have entered Barcelona. So you have entered Barcelona after using pushback Barcelona y, because we have used y over here. We want to add y at the end of the string. So after using pushback Barcelona y and popback function after that we have used, and we know that it will delete the element from the end. So here we can see there is no y. Popback function have deleted the element. So this is our output. Next is if-else statements. If-else are two conditional statements that are generally used when we want to run the code based on some conditions. We run a block of code which is inside if statement only if the condition is true. For example, if the number variable here is equal to 10, then only the block of code will execute and will print the message you got it. Otherwise, it will run the else block and display the message written inside that block, which is not this one. So first of all, we'll create a new file. We'll go to File and click on this New File. Now, in order to save this one, we can click on Ctrl S, or we can go over here and click on this Save As. Now we can select the location, like let's keep it over here only. Let's name it as visual.cpp. .cpp is the extension which is used when we want to do a program in C++. Now we'll click on this save button. Now let's do a simple program to check whether the program is running on this code editor or not. So we'll include the header files, #include iostream. Now we'll write namespace standard. Now we'll write int main. Now inside int main we'll display a message, welcome to this video. Okay, now return 0. Make sure to save this after making changes, or you can click on Ctrl S, or you can go to File and click on this save. So once you have saved the program, now you can run it. We can click on this play button, it will run the code. As we can see in the output, welcome to this video, we can see. Here it is. So it means our program is working, it is running fine. Now let's do another example in which we will take the inputs from the user. So let's make a new file. We'll go to file and click on this new file. Now we'll save as, and we'll write visual2.cpp. Alright, in this program we'll take the input from the user. So start with header files, #include iostream. Our spelling is wrong. #include iostream, after that using namespace standard. Now inside int main we'll take the inputs from the user. We'll display the message, enter the first number. Now using cin, we'll take the input. We forgot to mention this, declare this n1 variable. So we'll write int n1, int n2, and int sum equals 0. Alright, here we have taken the input of n1, the first number. Now we'll take the input of another number by displaying the message, enter the second number. We'll write n2. Now we'll add both of these, n1 plus n2, and we'll display the result. We'll write end line so that it looks good. Alright, now we need to save it. We'll go to file and click on this save. Now it is saved. Now we can run this program. We'll click on this run code. Now in order to write the first number over here, that is, in order to write in the terminal, we have to configure the Visual Studio Code. And to do that, we'll go to file and we'll now go to preference, and in the settings we'll click on the settings, and here we will type run in terminal. Alright, now we can scroll down and here we can see code runner run in terminal. In my VS Studio it is already marked, but you have to mark this if you want to write in terminal or enter the inputs in the terminal. Alright, once you have marked this, you can close it and then you can Ctrl S, that is save, and then you can close the VS Studio and then open it again. Once you are done, now let's try to run this. So now you will be able to write the inputs, like let's say 4. The first number is 4. Now the second number, let's say 9. On addition it becomes 13, which is the right answer. So these were some configurations that you need to do if you want to run a program of C++ in Visual Studio Code. So as we have understood how to download and configure Visual Studio Code for C++ programs, so let's move on to learn how we can download dev C++ and run C++ programs in that. So let's go to Google and type dev C++. This is the first link. We'll click on that. Now this is the green button saying download. We'll click on that to download dev C++. As you can see, it is getting downloaded. Your download will start shortly. So now we'll click on download now. Now it is getting downloaded. It will take a while. The size of this file is 48.1 MB. So as you can see, the downloading is almost done. So the downloading is complete. Now we'll click on open folder. Here it is, dev C++ setup. Now we'll click on this setup. We'll click on yes. The setup is loading. So now here we will select the preferred language. It is English. We'll click on OK. Now we'll click on, this is the license agreement. We'll click on I agree. Now we'll click on next. We don't need to change this. I think the space required is 346.8 MB, and we'll click on next. Now if you want to change the destination folder, you can, but I don't want to change it, so I'll click on install. Now it is getting installed. It will take a while. It's done, and now we'll click on finish, and it is marked. So when we click on finish, it will launch the dev C++. So here we have to select the language. It is English, so we'll click on next. Here again we'll click on next, and now we'll click on OK. So this is our code editor, that is dev C++. So let's write a code. First of all, let's create a file. We'll go to file and go to new, and we'll click on source file. Alright, now we need to save this one, and in order to save this, we'll click on file, then we'll go to save as, and now we'll select the destination and name it as dev.cpp. Alright, now let's start with the header file, hash include iostream. We'll do a simple program over here. using namespace std because we want to check that whether the program is running in this editor or not. Namespace std. Now we'll write int main. Inside int main we'll display a message, welcome to dev C++. Alright, after that we'll write return 0. Now let's try to run this, and in order to run this program we'll go to execute, and now we'll click on compile and run. Here this is the pop-up, welcome to dev C++. As we can see, this is the output. Now press any key to continue, it will close this window. So our output is correct, welcome to dev C++. So this is how you can run a program in dev C++, and our program was also working fine in the Visual Studio Code. So this is how you can download both of these code editors to run the C++ programs.
Today we'll be discussing about loops in C++. So let's begin and see what's in it for you. So we are going to be learning today about while loops, what is a loop, then different types of loops like for loop, while loop, do while loop, then there is nested loop. After that, there are control flow statements like break and continue. But before we begin, if you're new here and haven't subscribed already, make sure to hit the subscribe button and the bell icon for interesting tech videos. So let's start with the first topic, that is while loops. In order to perform a particular task or operation many number of times, we need loops. These are used when we want to execute a block of statement repeatedly rather than just writing those statements again and again. For example, imagine you want to display your name on the screen 50 times. Now to do that, there are two methods. Method 1 is writing your name 50 times by doing the hard code. And method 2 is writing your name once with the loop condition, and your name will be automatically displayed 50 times. Now it is pretty obvious that you would prefer the second approach because you don't have to put effort in writing your name 50 times. Plus, it is easy to write code in few lines. So method 2 is the functionality of loop. It reduces time in writing the code, plus it increases the simplicity. Now let's understand what is a loop. Loops in computer programming is a series of tasks that are used to run some particular code repeatedly until a specific condition is met. Loops tells the computer when to start the condition and when to stop it. Now, this is a basic flow of a loop. After the initialization, the condition is checked. If it's true, then the block of statement will get executed as long as the condition is true. And if the condition is false, the loop will terminate. Depending on the program, different types of loops are used in different times. So let's first see different types of loops. First is for loop, then while loop, then there is do while loop. After that, there is nested loop. These are four types of loops in C++. So let's discuss these loops. First is for loop. It is a repetition control structure that is used to iterate a piece of code based on the condition is true or false. If the condition is true, the statement inside the loop body is executed, and once if it returns false, the execution of statement will get terminated. And after every execution of for loop, the increment or decrement parts will update the loop counter. Now let's move on to the while loop. In this loop, the condition is evaluated first. If it's true, then the set of instructions inside the loop body will execute, and this will happen repeatedly until the condition becomes false. And when it becomes false, the loop will end. Now the main difference is we use for loops when we know the number of times the body of the loop needs to run, whereas we use while loops when we don't know the accurate number of times the body of loop needs to run. Now moving to the next loop, that is do while loop. This loop is quite similar to the while loop. In this, the loop will execute the set of instructions once before checking if the condition is true. After that, it will repeat the loop as long as the condition is true. That means, in do while, loop body will execute at least once irrespective of the test condition. Now coming to the nested loop. When one loop is defined inside the body of another loop, then it is known as nested loop. In C++, there are at least 256 levels of nesting, and the flow of execution for nested loop is: first it includes initialization of variable, followed by condition 1. If it gets satisfied, then it will search for the second condition. If that also gets satisfied, then it will get increment, and when the condition gets satisfied, it will search for the new set of statements, and follows the same flow of execution.
In C++, break statements are used to terminate the execution of the loop. And by terminating the execution of loop, we means finishing or stopping the execution. Like if we want to block or terminate a loop at some point, all we need to do is to use the break statement with a condition on which we want the loop to stop, and it will terminate the loop's flow or iterations. So break statements are mainly used for two cases. One is it can be used inside the loop, and second is it is mostly used in switch statements. And this is the loop's flow diagram, in which first there is a loop body, then if the condition is true, then there is a break statement which will terminate the loop, and if the condition is not true, then the loop will continue to iterate. As we can see in this example, the loop is iterating from 0 to 10. Inside the loop, there is a condition and then the break statement, which will make sure that the loop will terminate when I becomes equal to 4. After the break statement, the control will jump out of the loop body, and that's how the break statement works. Its output would be 0, 1, 2, 3. It will not exceed 4 because of the break statement. Now, coming to continue statement. The continue statement is a bit similar to the break statement, as it is also used for termination. But the difference is that it is used to terminate the current iteration and not the complete loop. For example, if a loop is iterating from 0 to 6 and inside the loop there is a continue statement on 4, then all the elements will be printed except 4, because continue statement skips that particular iteration and continues with the next one. And in break statement, the complete loop flow terminates. So when the continue statement is used, then within the loop, the control skips or terminates that particular iteration and continues with the next iteration. As you can see in this example, first loop body, then there is a condition. If that is true, then the continue statement will terminate and continues it with the next iteration. And if that is false, then control will go to the remaining part of the loop as always. Now in this example, we are using continue statement. Here the loop is iterating from 0 to 10. Inside the loop, there is a condition and then the continue statement, which will make sure that if the value of I becomes 4, then terminate that iteration and moves to the next iteration. After that, elements are getting printed with the help of cout function. Now its output would be 1, 2, 3, 5, 6, 7, 8, 9. It will not display 4 because of continue statements, as we know that the continue statement skip that particular iteration. So when we use I equals to 4, then it skips that particular iteration.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by SimpliLearn. Click on the link in the description to know more.
Alright, so as we have covered the theoretical part, so now let's do some examples on break and continue statements in our code editor, that is VS Code.
Now we'll make a new file and we'll name that file as loops.cpp. Okay, loops1.cpp. Now here we will do a program in which we have to print the digits from 0 to 10 using for loops. It will be a basic program just to understand it. We'll write the header file #include iostream. Now we'll write using namespace standard. Now here is the int main. Now we'll write the for loop with a for keyword. Inside the for loop, we'll initialize I with 0. Now we'll put a condition I less than equal to 10, which means the loop will keep on executing until I is less than 10. Now we'll put increment I++. Now inside the loop brackets, all we have to do is to print I, so that all the digits get printed. So now let me tell you, here what we are doing is, we are just making the loop to run from 0 to 10. As we can see that I have made I 0 to I less than equal to 10. That means loop will move from I 0 to 10. Now let's try to run it. Here we can see all the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here is our answer, and let me tell you one thing more. To put return 0 after the loop, it's a good practice. Now I'll again run it. The output will be the same, but it's a good practice to write return 0 in the end. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So instead of writing the hard code, we can just use the for loop in this case. It's a basic example of for loop, but you can try some more examples in order to understand it better. Now let's do one example of while loop to understand it better. We'll be doing a basic example of while loop in which all we have to do is to print Happy New Year 11 times. Let's start. First of all, let's name this file loops2.cpp. Now let's start with the header file, that is hash include iostream. Now we'll write using namespace standard. Now here is the int main. Now first of all, we'll declare n equals 0. We'll take a variable n and initialize it with 0. Now we'll put the while condition with the while keyword, writing while n not equal to 11. Here what it means is, the loop will keep on executing until n becomes equal to 11. Now here all we have to do is to print Happy New Year, so that it will get printed along with the loop 11 times. And then now we'll write n++. We have written n++ so that the loop will keep on incrementing every single time. After that, now we'll write return 0 outside the loop. Now we'll try to run this. So here's our output, Happy New Year 11 times. So this is how it's done. This is again a basic example of while loop, but to understand it better, one must practice some more examples on it. Now let's do one example of do while loop also. Let's make a new file. First of all, let's name that file loops3.cpp. I think the name is already taken. Then we'll write loops4.cpp. Okay, now so we'll write the header file. First of all, we'll write hash include iostream. After that, using namespace standard, now in this program, all we have to do is we have to print the sum of all the digits from 0 to 9. So let's start. We'll write int main. So now let's first of all declare a counting variable sum and initialize it with 0. Now we will initialize another variable I with 0. Now the syntax of do while loop is do keyword, and now we will add some code inside the body. We'll write sum equals sum plus I. Here what we are doing is we are simply adding sum variable and I variable and storing it to sum variable itself. We are doing this because we want to find the sum. That is why we have to store it in a single variable. Now we will need to increment I, or else loop is going to run forever. Now we will write file I less than 10. We have written I less than 10 because we want to find the sum from 0 to 9. And make sure to put a semicolon in the end in case of do while loop. Now we will print sum in this while loop. We'll write sum is sum variable. Now this loop will keep on executing till I is less than 10. Now in the do while loop, sum is calculated by repeated addition and increment. In each repetition, it is checked whether the number I is smaller or equal to the inputted number. If it is smaller, then the loop continues, but exits the loop if it isn't. After the control exits from the loop, sum is printed. Now let's try to run this code. Here it is. Sum is 45, which is the right answer. This is our output. So this is how it is done in do while loop. So now let's do one example of our last loop, that is nested loop. First of all, we'll name the file loops5.cpp. Now we'll start with the header files. Now using namespace standard, now in this program all we have to do is to print a star pattern of half pyramid form using nested loop. So let's try. We'll write int main. Now let's initialize two variables, that is I and j. Now let's say we want to make a half pyramid of 10 rows. Then it means we need to run a loop which runs for 10 times. So let's write for initialize it with 0, I less than 10 I++. Now here we have written I less than 10. Instead of this, we'll write I less than equal to 10 because we want the 10th row to be printed also. Now we'll print /n in order to insert a new line. Now we'll write another for loop which will decide number of stars in a particular row. So we'll write j equal to 1 because this for loop is for the column section. Then j less than equal to I, which is a row. Then j++. Now we'll print star. Now one more thing, instead of 0 we'll write I equals to 1 because we want to print stars from 1 to 10. So now let's discuss its working. Initially we have I equals to 1, that is the outer loop value. Now for this value a complete run of jth loop is happening, that is j equal to 1 validated by j less than equal to I. Now this condition is used because the pattern which we are going to build is having increment of star as the number of rows increments. So for I equals to 1, j equals to 1 is executed. Then j++ is done, which increments the value of j to 2. Now j equals to 2 failed to execute as 2 is less than equal to 1 is false. Therefore only one star is printed. Again we go to ith loop. Now for I equal to 2, we'll check every value of j which can be executed, that is 1 and 2. Since only two values can be true, therefore 2 stars are printed. Similarly, we check for I equal to 3, 4, 5 and so on till 9, as we have the condition I is less than 10. So now we'll try to run this and check whether the pattern is printing or not. Here it is, half pyramid form using stars with the help of nested loops. So this is our star pattern. We can make some more different types of patterns using nested loops, but we have done only one example in order to understand the concept. So now let's move to our control flow statements and let's do some examples of them. Okay, now make a new file and let's name this file as control1.cpp. Now we'll write the header file and the namespace standard as we have done previously. So let's do it. #include iostream using namespace std. Now here we will write a program in which we have to print the numbers from 100 to 200, like 110, 120, 130 with a gap of 10. But after 150 we will terminate the ongoing loop. Now how can it be done? With the help of break statement. So let's start. First of all we'll write int main. Now we'll take a variable num and initialize it with 100. Now we'll write a while condition and we'll write num is less than equal to 200 because we want the loop to run from 100 to 200. Num less than equal to 200. Now we'll simply display those numbers. Now we'll write an if condition that if num equals 150, then we'll terminate the loop. And for that we have to write the break statement inside the if statement. So let's write if num equals 150, then we have to break the loop. Write the break statement. Now after that we'll increment this by 10. We're incrementing this by 10 because we want the numbers to be printed like 100, 110, 120 like this. That is why we are incrementing it with 10 and not with 1. Now we'll write out of the loop just to be informed that we are finally out of the loop. Return 0. Now we'll try to run this. Here we can see, here we can see 100, 110, 120 up to 150. After that we are out of the loop. This means the code works fine. So this is the example of a break statement. Now after this we'll do another example of continue. So let's start. Let's make a new file and name it control2.cpp. Now we'll write the header files. Using namespace standard. Now in this program all we have to do is to print the numbers from 100 to 90, only excluding 96 from them. Now how do we do it? With the help of continue statement. So let's start. First of all we'll write int main. Now we'll declare a variable num and initialize it with 100. Now we'll write a while condition, while loop, in which we write the condition num greater than equal to 90, because we want the loop to run till it is equal to 90. That is why we have wrote greater than equal to 90. Basically we want the loop to run from 100 till it becomes equal to 90. Now inside the loop we'll write the if condition in order to skip 96. So we'll write if num equals 96, num equals 96. Now we'll use a decrement operator because our starting point is 100, our ending point is 90. That is why we have to use the decrement operator. Now continue statement. After that we'll write value is, and we'll write the variable num. Now we'll write num minus minus. Here we are writing minus minus because we want it to get decrement after printing also. That is why we have written num minus minus after printing num. Now let's try to run this also. Hope it works. Okay, I think there are some errors. So some brackets were missing. And we'll write return 0. Now we'll try to run it. Here it is. As we can see, 100, 99, 98, 97, but 96 is missing. So this is all we have to do in this program. And this is the basic example of continue statement. In order to understand these examples better, you must try more examples on each of these loops and control flow statements so that it will be easier for you all. Today we'll be discussing about C++ functions. So let's go ahead and look what's in it for us. First, we'll discuss what is a function. Then we'll understand why we use functions. Then types of functions like built-in function and user-defined function. Then function declaration. After that, function calling. Then function call methods. And at last, we have recursion. Also, don't forget to subscribe to our channel and hit the bell icon to never miss an update. Moving on to the first topic, that is what is a function. Functions are blocks of code that are designed to perform a specific task. It basically divides the complex problem into smaller portions and make the program easy to understand and reusable. And by reusable, it means we can define the code once and we can use it many times. We can also pass data into the functions in the form of parameters. And this is the syntax. First is return type of the function, then we will write function name, then inside the bracket, these are the parameters. Now, let's discuss why we use functions. Functions make the program less complicated because once function is defined in the program, then it can be used over and over again, which reduces the complexity of code. And it helps in avoiding the duplicity of code and it reduces the amount of code. Due to this, we can easily debug and maintain the code. Now, coming to the types of functions. There are two types of functions in C++, that is, built-in functions and user-defined function. Now, let's discuss these functions. First is built-in function. These are also known as predefined functions or library functions. We don't need to define these functions because these are already present in C++ libraries, and the implementation of these functions are also available in library file. And to use these functions, we don't have to write them separately, we simply call them. Now, coming to the user-defined functions. C++ allows us to define our own functions. These functions are created by programmers according to their requirement. This allows a way to wrap a set of statements to perform a specific task, and that group of statements is given a name so that it can be invoked later from any part of the program. Following is the example of user-defined function. Here club is a user-defined function with the return type void, and it is being called from the main function. Now, let's learn about function declaration. Function declaration basically acts as an identification for the function. It informs the compiler about the existence of function, function's name, the number of parameters in the function, and its return type. These things act as an identifier for a function. And this is the syntax for a function declaration. First, we will write the return type, then we will write the name of the function. After that, inside the bracket, we will write the number of parameters. For example, in this chess function, int is the return type, chess is the name of the function, and inside the brackets, these are the number of parameters. Although we can write the names of parameters, but names of parameters are not important in the function declaration, only their type is required. Now, let's learn about function calling. In order to use a function, we'll have to invoke or call a function. When a program calls a function, the control of the program is transferred to the called function, and when the called function completes its task, then the control is returned back to the main program. So the functions are called by writing the name of function, and after that writing the required parameters inside the brackets. And this is the syntax. First we will write the function name, and after that we will write the arguments which we want to pass. For example, sum is the function name and a and b are the arguments.
So first is call by value. Call by value is a method in which copies of variables are passed to the functions. And as the copies of variables or arguments are being passed, so that is why the changes that are done inside the function does not affect the arguments. And this is the syntax. Inside int main, we can see that we are calling a function and passing the values. Here val1 and val2 are the actual parameters. These are those which are passed to the functions. And inside the brackets of called function we can see n1 and n2. These are formal parameters. Formal parameters are those which are received by the function. So here we can say values of actual parameters, that is val1 and val2, will be copied to the formal parameters, that is n1 and n2. Now let's have a look at an example in which we are swapping two numbers. As we can see, inside int main we have assigned 120 to x and 150 to y. After that we have called a function named swapIt, and inside the brackets we are passing the values of x and y, and these values are getting received by called function, and inside that function there is a logic to swap the code with the help of temporary variable temp, and these values of x and y are then displayed inside int main. But its output is same. X is still 120 and y is still 150. There is no change after swapping it also. So this shows that actual value of the variable is not getting modified. This shows that changes done to the parameters inside the function does not affect the arguments. Now let's learn about call by reference. In this method, instead of passing the arguments, the address of the argument is passed to the formal arguments of the function, and the address is used to access the actual argument referring to the same location, so any changes that are made gets reflected to the actual parameter. This is the syntax of call by reference, in which we have assigned 200 to the variable num, and then the address of this variable is passed to the function and 20 is assigned to it. Now on displaying the output, the value would be 20 and not 200 because the value is assigned to the memory location. That is why change is getting reflected. Now let's have a look at an example of swap. This is the same example as that of the call by value, but instead of passing the copies of variable, we are passing the address of the variable, and inside the function values are getting swapped with the help of temp variable, and then it is getting displayed in the main function. In this case we can see in the output the values of variables are actually swapped. M is now 300 and N is now 250. Now let's do some examples of call by value and call by reference in our code editor, that is VS Code. Now we will do an example of call by value in which we will try to change the salary with the help of a function. So let's start. First of all, let's make a new file and name it call1.cpp. Now we will include the header files #include iostream. Now we will add namespace standard. Now first of all we'll write int main. And we will declare a variable sal and assign a value 27,000, let's say salary, to this sal variable. Now we will call a function. Let's name that function as salary underscore change. And now inside the brackets we'll write sal, as we know that in call by value we pass the copies of the variable. So now we'll display that variable. We'll write value inside main. And now we will write the variable name sal and handle Now return 0. Now let's make the function salary change. We'll write void salary underscore change. It's void. Now here we will write int, the data type, and the variable s, that is the formal parameter. Sal here is the actual parameter and s is the formal parameter. Now we will assign as a new value, let's say 30,000. Here we have assigned as 30,000. Earlier the value of sal was 27,000, and then we passed the copy of the variable sal to the function salary change, and there we assigned 30,000 to it. So let's print over here value inside function. Sal and L. Here we have to write S because the variable name is S. Okay, now let's try to run this. Here we can see value inside function is 30,000 and value inside main is 27,000. Here we can see the value of the variable that is passed gets changed, but the original value inside the main function doesn't changes. So we can say changes are not reflected to the original value, which happens in call by value method. So now let's do one example of call by reference. Let's make a new file, call2.cpp. Let's include the header files, hash include iostream, now we'll write using namespace standard. Now we'll start with int main. Here we will declare a variable sal and assign 27,000 to it, as we have done previously. Now we'll call a function named increment. And inside the bracket we will pass the address of sal. As we know that in case of call by reference we pass the address. So after that we'll just write the message saying salary inside main, and we'll write the variable sal, then endl. After that we'll write return 0. Now our job is to write the function. We'll write void increment and here we'll write ampersand sign s, because here we are passing the address, not any copy of the value or the variable. Here we are passing the address of the variable, so that is why we have used ampersand sign. Now we will simply write the logic to increment. So we'll write s equals s plus 5000. Let's say we want the salary to increment by 5000. Then we will display the variable s. So first of all we'll write the message salary inside function. The name of the variable, after that and L. Now let's try to run this. Here we can see that the salary inside the function is 32,000 and salary outside the function, that is inside the main function, is 32,000 as well. Here we can see that the changes are reflected to the original values as well in the main function, and we know that in case of call by reference, any change inside the function is reflected outside the function because we are passing the address of the variable. So this is our output, 32,000 and 32,000. So these were some basic examples of call by value and call by reference.
Now here we will do a program in which we have to do the sum of two integers with the help of function. So let's first of all make a new file, function.cpp. Okay, so let's start. First of all, we'll declare the header files, that is hash include iostream. Now the namespace standard. Now we'll write int main. Now inside int main, we'll declare a variable named s. Here we have declared this variable because we want to store the sum of those two integers in this variable. So we'll call the function, let's name the function as sum, and let's assume the variables to be 5 and 5. Here sum is the name of the function and 5, 5 are the arguments. Now we'll make the function sum. Here int is the return type, sum is the name, and int a, int b are the parameters. So in this function, we'll write the code to do the sum of these two integers, and for that we have to store the sum in a variable. For that, we will now declare a variable c. Now we will write c equals a plus b. Here we are storing the sum of a plus b into the variable c. Now as we know that the return type is int, so we have to return the variable instead of printing it. We'll write return c. Now in the main function, we'll print that variable. We will print the variable s because after the function completes its task of addition, the output will come back to the calling function, which is getting stored in the variable s. So we'll write the result is now we will write the variable s. Let's see. Hope it runs. The result is 10. 5 plus 5 on addition will get 10. Let's write 3 and again try to run this. The result is 8. 5 plus 3 equals to 8. So this is the right answer. Now we will do another example of C++ function in which we have to find the larger number or greater number among two elements. So let's do that. Let's create a new file. function1.cpp. Now we will include the header files hash include iostream. Now using namespace standard, now first of all we'll write the int main. Now the variable n1. Now we will declare another variable n2. These are the two variables among which we have to find the greater number. So we'll display a message saying that enter the first number. Now we'll take the input n1. Now we'll do the same for the other one. We'll write enter the second number. We'll input the second number. Now we have to make a call to the function named, let's say, maxi, and we will pass these arguments n1, n2. Now let's make this function maxi. The return type is void. Maxi is the name. We'll write the variables n1, n2. Now we'll write the if condition because we have to find the greater number among both these elements. So we'll write the if condition. If n1 is greater than n2, then it must print the n1. So we'll also display a message saying that the larger number is n1. If n1 is greater than n2, then we'll display the n1, and if n2 is greater, then we'll display the n2. We'll write the variable n2. So let's see if that runs or not. I think we have to write the first number. Here we can see enter the first number. Enter the first number. So we'll write, let's say, 56. and the second number would be 78. The larger number is 78. So among both the numbers, as we know that 70 is greater than 56, so this is how we can show it with the help of functions. So these were some basic examples of C++ functions.
In today's session, we will learn about C++ recursion. Now, let's have a look at what we'll be covering today. First of all, we'll discuss what is recursion. Then we'll understand the working of recursion, that is how it actually works. After that, we will learn about types of recursion, and at last we will go through the advantages and disadvantages of recursion. So, what is recursion? Recursion can be defined as a process in which a function calls itself again and again until a certain condition is met. Recursion basically brings about several number of iterative calls to the same function. However, it is important to have a base case to end the recursion. For example, imagine you are calling your friend again and again for an urgent piece of work until he picks up the call. Now, here calling your friend again and again or one after the other is a recursive function, and when he picks up your call is the termination condition. And this is the basic syntax where the function name is recursion and it is being called from the main function, and inside the recursion function it is calling itself. Now let's understand its working. In a recursive function there are two parts, that is the recursive case and the base case. In the recursive case, the function is being called by itself again and again, and the base case is when the function finally stops calling itself. So when the recursive function is called from the main function, then the called function will execute and it keeps on repeating as it is being called by itself from within the function again and again until it meets the base case that will terminate its calling. For example, factorial of 5. In this problem, we can see a pattern, n into factorial of n minus 1. To be clear, n is 5. So n minus 1 is 4. And it is going on till n becomes 0. Here factorial is the recursive function and n minus 1 is the argument that is getting passed for every n into the recursive function. In this case, if n becomes 0 or 1, it is the base case and n into factorial n minus 1 is the recursive condition. Now, let's understand the types of recursion. First is direct recursion. As the name suggests, in this type of recursion, function calls itself directly. For example, void recursion. Here recursion is the name of the function and is being called by itself from within the function directly. Although there is no base case in this example, but it shows the idea of direct recursion. Now, coming to indirect recursion. When a function calls itself indirectly, that is, if a function calls some other function to make a recursive call, then it is known as indirect function. For example, here recursion function is calling some other function sub, and sub function is calling the recursion function. Here both the functions are calling other functions to make a recursive call. This is called indirect recursion. Now, coming to advantages and disadvantages of recursion. The advantages are, in recursion, we only need to define the base case and the recursive case. So, therefore it provides a simple and clean way to write a code. Second is, recursion is more preferred in problems like tree traversals, Tower of Hanoi, graphs, because these are inherently recursive problems. Now, disadvantages. Disadvantages are, the recursive program generally acquires more space than the iterative program. This is because after every call to the function, each function call will keep on adding to the stack until the base case is reached. Second is, it requires more amount of time because of function calls. Now, let's do some examples of recursion on our code editor, that is VS Code. Now here we will do a program in which we will find the sum of natural number up to a number which we will enter, and we will do this example using recursion. So let's start. First of all, we'll name this. Recursion.cpp. Okay, now we will start with writing header file, that is #include iostream. Now we'll add namespace standard using namespace std. Now first of all we'll write int main. Now we will declare a variable, let's say num. So basically we want to enter a number. So for that, first of all we'll display a message saying that enter a number. Now we'll take the input as num. So now here we will make a call to the function, and in that function we will pass the variable num which we have taken the input of, and we will print this with a message. So let's say we'll print it like cout, and the message would be sum is, and this is the function name sum, and this is the variable which we are passing. After that let's write return 0. Now let's make this function sum. We'll write int, the return type, sum, the name of the function, and the variable num. Now first of all we have to make a base case. So we will write the base case as, we'll make if num is not equal to 0, then here we will write the recursive case, return num plus sum num minus 1. So here we are adding the numbers with its previous number, and because of recursive condition it will keep on calling the same function, sum function, again and again till the base case, that is num becomes equal to 0, is achieved, and once it is achieved the calling would be stopped. Num not equal to 0 here means that if num is not equal to 0, then only this statement num plus sum num minus 1 will execute. Okay, so now after this we'll try to run this. Enter the number, let's say 5. Sum is 15. Here we can see sum is 15. Okay, let's recheck. 5 plus 4 equals to 9, 9 plus 3 equals to 12, 12 plus 2 equals to 14, 14 plus 1 equals to 15. So our answer is correct. So this is how we can find the sum up to any numbers which we want to find the sum of. And now let's do another example. So let's name this as recursion 2.cpp. Now here we will do a program of factorial. We will enter a number and we have to find the factorial of that number. So let's start. First of all we'll write #include iostream, that is the header file. Now using namespace standard, now we'll write int main. Okay, now we will declare a variable number, and we want to take the input from the user, so we'll display a message saying enter the number. Now we will take the input, we'll write number. Now we will call a function and we will pass the argument number as we have done in the previous question. So let's do it. First of all, we'll display that saying the factorial of the number you have entered is. Now we will make a call to the function. Let's say the name of the function is fact, and we'll pass the argument number as we have done previously. Now we'll write return 0. Now let's make this function. We will write the return type int. Now fact. After that, now we will write the argument int number. Now we will write if condition and we'll write number less than 1, and we will return 1. So here we have wrote this condition because as we know that the factorial of 0 is 1, and if a number is less than 1, that it means it is 0, and if it is 0, then our program should return 1. And we will write now else condition, else if it is not 0, that means we will write the recursive condition, that is number into fact number minus 1. Now this is the condition that is responsible for finding the factorial of a number. For example, if we input 5, then here we can see the condition would become 5 into fact 5 minus 1, that is 4. And this 4 will be passed as argument to this fact function. And then the condition would become 4 into fact 4 minus 1, that is 3. And it is also passed to the function. And similarly, it will go on until it becomes less than 1. Now let's try to run this. Enter the number. Let's say 6. The factorial of number you have entered is 720, and we know that the factorial of 6 is 720. So this is the right answer. And let me tell you, this is the base case and this is the recursive case in this program. Now after that, let's do one last example of recursion. Okay, so now let's make a new file and name this file Now first of all, we'll add the header files, iostream, now namespace standard, using namespace standard. So here we will do the program of Fibonacci series, and we know that Fibonacci series is basically in Fibonacci series each number is basically the sum of its two previous numbers. So let's start. So first of all, we'll make int main, Now we'll declare a variable num. Now we want to take the input from the user. So first of all, we'll display a message saying that enter the number. Now we'll take the input. We'll write num. Now we will make a for loop and iterate that loop from I0 to num. So we'll write for keyword int I equal to 0, I less than num, I plus plus. Now inside the loop we will write cout to display, and we will call Fibo function, and we will pass I as an argument because we want to print the series. So we will write cout Fibo, and we'll pass I as an argument, and just for the space now we'll write return 0. In Fibo function we have passed I as an argument because we want to print the series. So first 0 will be passed, then 1 will be passed, after then 2 will be passed, and so on. So now we will make the function Fibo. Int is the return type, Fibo is the name. Now the argument num. Now in this Fibo function we will put if condition for checking if the num is equal to 0 or 1. If yes, we will return the value of num, else we will recursively call Fibo using n-1 and n-2 because Fibonacci series is basically the sum of previous two numbers. So first of all we'll write if num is less than equal to 1, then return num, else return Fibo num minus 1 plus Fibo brackets num minus 2, because we know Fibonacci series is basically the sum of previous two numbers. Now if the num is 0 or 1, then it will go to the if statement, and if it is greater than 0 and 1, then it will go to this recursive statement. So for example, if n equals to 2, then we will call recursively 2 minus 1 and 2 minus 2, that is 1 and 0 respectively. Since 2 minus 1 will give 1 and 2 minus 2 will give 0, these will be evaluated in if statement as they are less than equal to 1. So it will give 0 plus 1, that is equal to 1. Now let's try to run this code. Enter the number, let's say 6, 0, 1, 1, 2, 3, 5, which is the right answer. The Fibonacci sequence for 6 is 0, 1, 1, 2, 3, 5. So this is how we can do Fibonacci series or Fibonacci sequence with the help of recursion. And I suggest you to do some more examples on recursion to understand it better. In this session, we will learn about friend functions in C++. So let's go ahead and have a look at what we'll be covering today. In this session, we will cover topics like why do we need a friend function, what is a friend function in C++, then the declaration of friend function, and after that, we will learn what is a friend class, then we will understand features of friend function and its advantages. But before we begin, make sure to subscribe to our channel and hit the bell icon to never miss an update. So first is, why do we need a friend function? Friend functions are used when we want to access the private or protected members of the class, but without the help of the objects. It helps us in avoiding the case where the functions must be a member of both the classes in order to access them. Or, in other words, a function doesn't have to be a member of both the classes in order to access the class data. A friend function is also used to perform operator overloading. Like functions, operators can also be overloaded, and because of the friend function, it is possible. Now, let's understand what is a friend function. A friend function is not a member function of the class, and it is defined outside the class. And we know outside members cannot access the class data, but the friend function can access those private, public, and protected class data, because the friend function is friendly with the class. Now let's move to declaration of friend function. The declaration of friend function must be done inside the class. The friend function is declared using the friend keyword, then the return type, then the name of the function that is made a friend of the class. Its definition is done outside the class, and we don't use the friend keyword while defining it. But while declaring it inside the class, we use the friend keyword. Now, coming to the next topic, that is, what is a friend class? Exactly like a friend function, a class can also be a friend of another class. A friend class is that class that can access the data members and member functions of a class to which it is a friend. We need to pass the objects of the class to a member function of the friend class if we want to access those private and protected members. Also, if the classes are declared friends, then all the member functions of the class will be a friend function to the friend class. Now, let's have a look at the syntax. Here we have done the forward declaration of class table. This will allow the access of the objects of the class table in the class club. Inside the class club, we have declared friend class table. That means the class table is a friend of class club, and it can access members of that class. After that, we have defined the class table without the friend keyword, as we can see. Now, coming to features of friend function. So here are some features of friend functions. So let's start with the first one, that is, a friend function can be easily invoked just like a normal function. It doesn't require any object or so to invoke. Next is, the scope of a friend function is not limited. It can be a member of another class as well. Third is, a friend function can be declared in any part, that is, private, protected, or public parts of the class. Fourth is, the object of the class can be used as an argument for the function. And the last is, a friend function can access the members by using the object name and dot operator along with the member's name. Now, coming to advantages of friend function. The first advantage is, with the help of friend function, we are able to access the non-public members of the class, that is, the private members. The second advantage is, friend function helps in operator overloading. And the third advantage is, because of the friend function, we are able to share the private information by a non-member function, as friend function is not a member function. And the last advantage is, friend function allows us to generate more efficient code. So these were some advantages of friend function. So now let's go ahead and do some examples on friend functions to understand it in a better way. So let's open our Visual Studio Code and do some examples. So first of all, let's make a new file. Let's name it friend1.cpp. Alright. So now here we'll do a simple program of friend function. So let's start with including the header file #include iostream. Now we will write using namespace standard. Alright, and inside the main function, first of all we will create an object of a class. Let's say the name of the class is salary and the name of the object is s. Alright, after that we will simply write return 0, and we will do the rest of this after creating the class. So we need to first create the class. Now we'll write class salary, which is the name of the class, and inside this class first of all we'll write private access modifier, and here we will write or declare a variable named cell. After that, now we will write or declare the friend function. So we know how to declare a friend function. We'll write friend keyword, then the return type, that is int, and then the name of the function, let's say increment, and then the objects. As we know, we have to pass the name of the class with the object because we want to access the private member of the class. So salary s, which is the object, and after the class we'll write the semicolon. Now we have to create or define this increment friend function. We'll write int increment. Here we haven't used the friend keyword because this is the definition. Now inside the arguments we'll pass the object. Alright, now inside the main function we will call this friend function. So first of all we will display a message saying that increment is, that the increment in the salary is, and then we will call this function and we will pass this object. Alright, now inside this increment function, which is a friend function, we will use object s dot operator and then the name of the variable, which is private. Now all we need to do is to increment this salary variable. So we'll write s dot sal plus 7000, which is the increment, and then we will return s dot sal. Alright, now as we can see, this increment function, which is not a member function of this class, is accessing this private variable of salary class and is incrementing 7000 to the salary. So now let's save it first and let's try to run this. There is some error. Let's have a look at that. Alright, yeah, there is some spelling mistake, increment. Now let's save it and run it. So as we can see, increment is 7000. So this is the correct output. So this was a simple example of friend function. Let's do another example. So here we will do an example of friend class, and we know friend class is a class that can access the data members and member functions of a class to which it is a friend. So let's start. First of all, we'll include the header files, hash include iostream, and then the namespace standard. And we forgot to name this file, so let's do it. Let's name it friend2.cpp. Alright, now let's proceed. Int main. Inside the main function, first of all we will create an object of a class. Let's say the class name is num2 and its object is obj2, object2. Now for now, let's say we'll write only return 0. We'll do this part later onwards. Now let's create the class. Alright, so the class name would be num2, num1 actually, but we know in friend class we have to do the forward declaration. So we will write class num2. So this is a forward declaration of class num2. Now inside class num1, first of all we'll declare a variable in private. So let's say the name of the variable is int n1. Int is the data type, n1 is the name of the variable. Now we have to do the declaration of friend class. So we'll write friend keyword, after that class num2, which is the name of the class. Alright, after this let's create this. First of all we have to put the semicolon. Alright, now let's write this class num2. So this is our friend class num2. We haven't used friend keyword over here, as we can see. Alright, in this class we'll use the private access specifier and we'll create another variable n2, and then we will write the public access specifier and we will create a constructor of num2, as this is the name of the class and this is object we have created. So now we will create the constructor of this class num2, and now in this constructor we will initialize n2 with 65 or whatsoever number we want. because in the end we have to find the average of two variables. So this is the second variable n2, and we have assigned the value 65. So now let's make the function of average, because we want to find the average of both the numbers. So int is the data type, avg is the name of the function, let's say, and inside this function we will make an object of num1 class, and the object name is obj1. Now as we have created the object, by mistake we have wrote I obj1. So as we have created the object of num1 class, so its constructor would be invoked, which we will create now. But first of all, here we will write return the average. So we'll write obj1 dot n1 plus n2 divided by 2. So as we know that obj1 is the object of num1 class, so that is why we have used obj1 dot operator n1, that is the name of the variable, plus n2 divided by 2. From here we can find the average, and before that we have to create the constructor of this class. So now all we need to do is write public access modifier, now num1, and inside this num1 we will assign the value to n1 variable, which is, let's say, 11. Alright, so now in the main function we have to call this function avj, that is the average function, and we forgot to put semicolon over here. Alright, now we'll display a message average is, and now we will call the function obj2 dot avg, which is a function. So here we are calling this function. So let's save this. So we have saved this. Now let's try to run this one. As you can see, the average is 38. So 65 plus 11, 6, and 76 divided by 2, which is 38. So this is the correct output. So this is a fine example of friend class. As we know, class num2 is a friend of class num1, so it can access all the members of class num1. In class num2 we have created the function avg over here. This is the function avg. Here we are doing the average of both the numbers, and as class num2 is a friend of num1, so we can create objects of num1 in num2 class. And after doing this, this is our output, that is average is 38. So this is an example of friend class. Now let's do another example. So here we will do an example of friend function, in which a friend function is a friend to two classes, and this would be an example in which we have to do the product of two numbers. So let's start. First of all, let's include the header files as we have done previously. iostream, namespace standard. Now let's save it, friend3.cpp, and spelling is wrong. Now let's start with the main function. Inside the int main, first of all we will create the object of class A, that is A, and class B object would be small b, and we will use these objects to call the functions, but we will do that part later onwards. First of all, we'll simply write return 0 over here, and now we will create the classes. Alright, so here we will create a class, but before that we have to do the forward declaration of another class. So this is the forward declaration of class B, and now we can create the class A, and inside the A class we will declare the variable x, let's say. Now we will use this public scope, and we will create a function within this class, let's say void assign. Now inside this function we will pass the variable I, because we have to assign the value of this variable I to the variable x. So we will assign the value of I to x like this, and before that we have to do the calling from the main function. So we will do that later. First of all, we will create the friend function, and here we are declaring this friend function. void is the return type, product, let's say, is the name of this friend function, and a comma b are the arguments. Now let's call this assign function first of all. So all we need to do is we will make a call from this main function a.assign, which is the name of the function, and let's say we have passed the value 45. Now here we will create the class b. Inside the b class we'll similarly create another variable y, and now inside the public scope we will create function of the same name, that is assign. Now in this assign function we will pass I as the argument, as we have done in class A. Similarly we'll do it over here. We will assign the value of I to this variable y. Once we have done this, then we will declare friend function. As we know that the friend function is friend of both of these classes, so we have to do it inside both of these classes. We have to declare the friend function, and now we will declare the friend function in this class as well, product. Alright, after the class we will use the semicolon. Now we will create the friend function. So here we are defining the friend function. We use void product, which is the name of the function. Now data type object name. Alright, now all we need to do is we'll do the sum a.x into b.y, and now we'll use semicolon. So here a.x will hold the value which have been assigned, that is 45, and now b.x, b.y will hold the value which we will call from here b.assign. Here we are calling and we are assigning the value, let's say 20. We are passing the value 20, and this 20 value will be assigned to this y, and 45 into 20 would be the product. So everything is done. Now all we need to do is to call the product function, and as we know that the product function, that is the friend function, is the friend of both of the classes, so it can access the private variables. So we'll do that, product a comma b. Here we are calling this. Now let's save this one and let's try to run this. There are some errors, let's check them. Class A, alright, so we forgot to make some space over here. Now let's save it again and let's try to run this. As we can see, the output is 900. So 45 into 20 is equal to 900, which is the correct answer, and it means the program is working fine. So this is a fine example in which a function, that is this product function, is a friend of both the classes, that is class B and this class A. Here we have done the forward declaration and we have made the friend of class A, and here we have declared the friend function in class B. And as we can see that this product function can use or access the private variables of both the classes, and so this is by using the private variables we have done the product of both of these numbers, and its answer is 900. So these were some few examples of friend functions. You can try some more examples on it. It will enhance your knowledge in C++ as it is an interesting topic. Welcome to this video on C++ header files. And in today's session, we will learn about why we need header files, then what is C++ header file. After that, we will learn about types of header files and how can we create our own header file. And at last, we will have a look at some examples of header files. Header files allows us to assemble all the predefined functions in one place, and it is helpful because it is easier to gather the declarations in one place and then use them whenever we need them. And as all the declarations are gathered in one place, so it automatically reduces the complexity and it also decreases the number of lines of code. There are many functionalities of header files. One of them is it helps in taking the input from the user and also helps in displaying the output in a program. Now let's learn what actually a C++ header file is. Header files are the set of libraries that contains predefined functions at a common place. So it basically stores the declarations at one common place and they are being used while writing a program. These header files usually have a .h extension and we use #include before writing the header file to inform the preprocessor that we are including this header file. Now let's discuss types of header files. There are two types of files in C++. First is predefined header file. These files are already present in C++ compiler. We simply need to import these header files using #include, which will inform the compiler about the header file, and then we can write the name of the header file between the angle brackets. Next is user-defined header file. These header files are defined or created by users. In C++, user can create their own header file and include it in the C++ library, and it can be used whenever it is required. Now let's learn how to create this header file. In order to create your own header file, first of all we will write the C++ code which we want to use whenever we want. After that, we will save the file with .h extension. As we can see in step 1, we have written the code of two integers that are getting multiplied, and now we will include this in the program. To include this in the program, we will use #include, and after that we will write the name of the header file inside the angle brackets with the .h extension. Here #include will inform the compiler that a header file is added. And now, as we can see in step 2, after the declaration of two integers, we are calling the function product and passing the arguments x and y. After running this program, we will get the output as 45. Because 9 into 5 equals 45, and we don't need to worry about writing the logic of it because we have already included this header file. Now let's have a look at some examples of header files. #include IOStream. IOStream is the header file that is used to read and write the standard input-output streams. Because of this header file, we can take the input and display the output. And in case of IOStream, .h is not used because after standardization of C++, IOStream became standard header whose function is now in std namespace. Unlike earlier when functions were defined in IOStream before standardization. Next is fstream. Fstream are associated with files. It is basically used to read the information from files and write the information in it. And next is iomanip. Iomanip is a library that is used in the manipulation of input and output statements. So these were some examples of header files.
Today we'll be discussing about C++ array. So without further ado, let's get started. So what's in it for you? We will start by understanding why do we need arrays, then what is an array, after that types of array like one-dimension array, two-dimension array, multi-dimension array, and then memory representation, and lastly we'll go through array initialization. So first is need of arrays. We use arrays because it allows us to store similar type of data within contiguous block of memory, and it allows us to iterate through those variables conveniently using indexing. Usually, an array is used to store similar kind of data like marks scored by all the students of a class and record of attendance of all the employees in an organization. Now moving to what is an array. An array can be defined as a collection of similar kind of elements. These are always stored in contiguous memory locations, that is one after the other. The total number of elements in an array is called the length of the array. Now this is the way you can visualize an array. Here each block is capable of storing data values of some type in sequential manner, and each element can uniquely identify by its index in the array. And this is the syntax of array. Int is the data type, array is the array name, and 5 is the size of array. Now there are few types of array in C++. Those are one-dimensional array, two-dimensional array, and multi-dimensional array. So let's first of all discuss 1D array. This is the simplest form of an array. In this array, data items are arranged linearly in one dimension, having single index value to represent data elements. Now this is the syntax of 1D array. Type is the data type, then there is array name, and after that size of array. And this is the example of one-dimensional array. Now coming to its memory representation. Here we can see 2, 7, 4, 8, 1, 6 are the elements inside the memory blocks, and 0, 1, 2, 3, 4, 5 are the indexes. So by using index, we can easily access the elements, and once the array elements are accessed, a number of operations can be performed. Here array of 0 means 2 and array of 1 means 7, and so on. As each element is of type int, that is 2 byte, that means the array occupies 12 contiguous bytes because each block contains 2 bytes and there are total 6 blocks. Now coming to the two-dimensional array. In this array, each element is referred by two indexes, that is rows and columns, and they are stored in the form of matrices. The first index shows a row of the matrix and the second index shows the column of the matrix. Now moving to its memory representation. As we can see, this is a 2D array with 3 rows and 3 columns. And we can also say that these are basically 3 1D array containing 3 blocks each, combined to form a 2D array in the form of a matrix with size of 3 cross 3. The horizontal lines depicts rows and the vertical lines depicts columns. And we know that index starts from 0, so first elements get stored at array 0 0, that is 0th row and 0 column. Then second element is stored at array 0 1, that is 0th row and column 1, and likewise all the elements are stored in the array. Now coming to the multi-dimensional array. These are defined as array of arrays, that means each element of multi-dimensional array is an array itself. They can have any number of dimensions and it stores the data in tabular form. A two-dimensional array is also a multi-dimensional array. And this is the syntax for a multi-dimensional array. Here, type is the data type of array, then array name is the name of the array, and size 1, size 2, up to so on size n are the dimension of sizes. After that, this is the basic example of a multi-dimensional array. Now, coming to the next topic, that is array initialization. So, there are two ways to initialize an array in C++. First is, you can initialize an array when you declare it by including the initial values in braces after the declaration. While declaring, we could use curly braces to set the values inside it. For example, in this array of size 6, the element 2 is at 0 index, 5 is at 1 index, 1 is at 2 index, and so on. If we don't mention the size of array, then the array will only be large enough to hold the elements added within the curly braces. Other than this, we can set the value after the declaration by assigning the element to the array using its index. Like array of 0 equal to 5, here we are assigning 5 to index 0, and array of 1 equal to 7, here we are assigning 7 to index 1, and same goes for the array of 2. Now let's do some examples on array to understand them better. We'll do these examples on our code editor, that is VS Code.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by SimpliLearn. Click on the link in the description to know more.
Now we'll make a new file. And let's name that file as array.cpp, array1.cpp. Now we'll do a basic example in which we have to print the elements of array. So let's start. First of all, we'll write the header file #include iostream. Now using namespace standard, now we'll write int main. Now we'll start by writing the data type int. Now we'll write the array name, that is, let's say coupon, and now the size of array, let's say 6. Now curly braces. Now inside these curly braces we'll write those elements, let's say 5, 8, 7, 3, 9, 1. So these are those elements, and this is our array declaration. Now here int means the data type, coupon is the array name, 6 is the size of array, and 5, 8, 7, 3, 9, 1 are the elements of array. Now after that we'll write the for loop with for keyword. Now we'll initialize I with 0, I less than 6 because it is the size of array. Now we'll increment I. Now in this loop all we have to do is to print this array. So how do we do that? So let's do cout, and inside the bracket we'll write I. So here we have printed the array inside the loop and we have put I inside the array bracket. Now the loop will run from I0 to 6, and likewise all the elements from 5 to 1 will get printed. So let's see. Let's try to run this code. So this is our output 587391. So this is how we can print the elements of an array. And if we want to print a particular element from the array, all we have to do is to write the index number of that element inside the bracket. Let's say if we want to print 7, all we have to do is to print its index number, that is 2. Now let's run this. See, 777. It is because of the loop that from I0 to I6. That is why it is getting printed 6 times. Now if we remove the loop and try to print it, then it will get print only one time. Let's see. Here 7, and this is what we want to print. Now let's do another example. Let's name this file array2.cpp. Now in this example all we have to do is to do the sum of all the elements of the array. So let's start by writing our header file #include iostream. Now using namespace std, now we'll write int main. Now here first of all we'll declare a variable sum and initialize it with 0. Now we'll declare another variable n, and n will depict the size of the array. So first of all, in order to scan array, first of all we have to scan the size of it. So we'll scan n. Now we'll declare the array. And inside the bracket we will mention n because it is the size. Now we'll write for loop, and we will initialize with I equals 0, I less than n, which is the size of array, and we'll increment I plus plus. We are writing for loop here because we want to scan the array, and as in this array there are more than one element, so that is why we need for loops. So now we will scan the array. We'll write cin, then name of array, and inside the bracket we'll write I. Now Here we have written I inside the brackets because we want to take input of elements from I equal to 0 to n, which is the size of array. Now we'll take another for loop. Now here we will write another for loop in which we are initializing I from 0 to n, and inside that for loop we will do the sum of the array. So we'll write equals to 0, I less than n, which is the size. Now we will increment I plus plus. Now inside this for loop we'll do the code, we'll do the logic of adding the elements of the array. We'll write sum. As we know that we have already initialized sum with 0, we'll write sum equals to sum plus array of I. Now for this statement sum equals to sum plus array of I, we are adding each value in the array one by one into the sum, which is initially 0. When I equals to 0, then the sum will be equal to 0 plus array of 0. And this sum will keep on getting stored inside the variable sum. As our I increments, our sum keeps on storing the addition value. Now we'll print this sum outside the loop. We'll write cout and we'll write sum is now we'll write the sum variable. Return 0. Let me tell you, return 0 is optional in C++. Basically, return value is exit status of the program and 0 is considered as OK. In C++, compiler includes it automatically, but it's a good practice. Here we forget to write the data type. Now we'll try to run it. So first of all, we'll write the size, like let's say 6. Now the elements of the array, let's say 1, 2, 3, 4, 5, and 6. Now we want to find the sum of these elements. Sum is 21. Let's recheck. 1 plus 2 equals to 3, 3 plus 3 equals 6, 6 plus 4 10, 10 plus 5 15, 15 and 6 is 21. So this is our right answer. So this is another basic example of array. So after this we'll do one example of two-dimensional array also. So let's make a new file and we'll write the header file. Let's name this file as array3.cpp. Now namespace standard. Now we'll write int main. Now we will declare a 2D array of 3 rows and 3 columns with elements inside it. Three rows, and in the second bracket we'll write 3 columns. Now we'll write the curly braces and another curly braces. This is the way to declare a 2D array. Now 2, 7, 9, let's say. Now again curly braces. 1, 3, 8. Because we are creating a matrix of 3 cross 3, that is why there are total 9 elements inside the array. So now we will create a nested for loop where the outer loop I, which is for the rows of matrix, is initialized from 0 to 2. We'll write int I equal to 0. Now I less than 3, I plus plus increment. Now we will write inner for loop j, which is for the column, and we will initialize it from 0 to 2 as well. We'll write for int j equals 0, j less than 3, j plus plus. Now we will print the array. In the first bracket we will mention I, that is the number of rows, and in the second bracket we will mention j, that is number of columns. And in order to add space, we will add space in the output. Now outside the bracket we will mention AND-L. Shift the elements to the next line. After that we'll write return 0. So this is our output 541279138 in the matrix form. That is why I have used this space to make the output look good, and this AND-L. So this is our output 541279138. So this is how we can print the elements of a multi-dimensional array or two-dimensional array. These were some basic examples of array, and in order to understand these programs you must practice more examples on it.
In this session, we will learn about sorting in C++. So let's go ahead and have a look at what we'll be covering today. We will learn what is sorting in C++, then the categories of sorting, which are internal and external sorting. After that, we will understand types of sorting in C++, that are bubble sort, selection sort, insertion sort, and quick sort. And at last, we will understand sorting using C++ library. But before we begin, make sure to subscribe to our channel and press the bell icon to never miss an update. So first is, what is sorting in C++? Sorting in C++ is a concept in which the elements of array are rearranged in a logical order. Now this order can be from the lowest to the highest or highest to the lowest. Rearranging them in a sorted order helps in dealing with many problems like searching the maximum element or the minimum element from an array of elements. In C++, sorting is categorized into two types, that is internal sorting and external sorting. So let's understand these. In internal sorting, the data to be sorted is present in the main memory, and the process of sorting will also take place in the main memory itself. While in case of external sorting, the data is not always present in the main memory because the data is large. So data is filled in the main memory in small portions. So this is the difference between internal sorting and external sorting. Now coming to types of sorting in C++. There are various types of sorting in C++, that are bubble sort, selection sort, insertion sort, and quick sort. So let's start with bubble sort. Bubble sort is one of the easiest sorting techniques in C++. In this technique, the comparisons are done starting from the first two elements. The adjacent elements are compared. If the element on the left is greater than the element in the right, then the swapping is done, and it will proceed till the end of the array. So first the comparison will start from the first two elements, that are 22 and 13. And as we know that 22 on the left is greater than 13. So we will swap these elements and make them 13 on the left and 22 on the right. Now it became 13, 22, 5, 7, 11. So now we will compare 22, which is at index 1, with 5, that is at index 2. And as 22 is greater than 5, we will swap these elements as well. Then again we will compare it with the next element, and if 22 is greater than that element as well, then we will swap them as well. So in this way, round 1 of comparison is complete, as one of the element reached its actual position. 2 more rounds of the comparisons will occur till the array becomes sorted. It is because for n elements the number of comparisons are n-1. So number of comparisons here would be 3, as the elements are 4 in numbers. Now coming to selection sort. In this selection sort technique, the smallest element is fetched by comparing itself with the rest of the elements and is sorted at the first position of the array. Once the first element is sorted, the search for second minimum element begins from the rest of the array and is positioned at the second place. Similarly, one by one, all the elements are positioned like this. So this is selection sort. Now moving to insertion sort technique. In this sorting technique, the elements are sorted by comparing the second element with the first element. If the second element is smaller than the first, then we will swap it. After that, we will compare the third element with all the elements that are before it. Similarly, it goes for the fourth element and so on. Once all the comparisons are done, the elements becomes sorted, as we can see in the figure. So this was insertion sort technique. Next is quick sort technique or quick sort algorithm. Quick sort algorithm is one of the most widely used algorithm and the most efficient sorting algorithm. The quick sort algorithm follows a divide and conquer approach. In this approach, a pivot element is selected and the array is partitioned into two halves on the basis of this pivot element. The elements that are smaller than the pivot element are shifted to the left side of it, and the elements greater than the pivot element are shifted to the right side of it. After this, both the left and the right subarrays are sorted and combined. For example, let's suppose we have 6 elements, 5, 15, 1, 8, 22 and 6, and we want to sort them using quick sort. So first of all, we will select any pivot element, let's say 6. Now we will divide the array to two subarrays based on the pivot element in such a way that the elements smaller than the pivot element are on the left and the elements greater than the pivot element are on the right. As you can see in the figure, elements smaller than 6 are on the left and elements greater than 6 are on the right. Now we will sort both of these subarrays separately. We will select a pivot element from each of the subarray. Like we can see, from the first subarray we have selected 5 and the second subarray we have selected 15. Similarly, if the element is less than the pivot element, then adjust it on the left, otherwise on the right. By doing this, both the subarrays will become sorted and now we can combine them to become a complete sorted array. So this is how quick sort algorithm works. So as we have understood about the sorting technique, now let's understand how to sort using C++ library. We can sort using the C++ library as well. To use that library function, we must include the #include algorithm header file. This function compares each and every element within the range. The syntax of function is sort, then within the brackets there will be the starting iterator and the ending iterator. and we must include this algorithm header file with hash include, which is a preprocessor. So as we have understood about these sorting algorithms, so let's move to our code editor, that is VS Code, to do some examples on these sorting algorithms. Alright, so this is our code editor, and here we will do some examples of sorting techniques. So let's first of all create a new file, and let's name it sort1.cpp. So let's add first of all the header file hash include iostream, then the namespace standard, so first of all we will do an example of bubble sort algorithm, and now we'll create the main function. Inside the main function we will create some variables, let's say int I, int j, and a temporary variable temp. After that we will declare an array arr, and let's say the size of the array is 8, and the elements of array are 12, let's say 3, 1, 5, 18, and 10, 7, and 35. So these are the elements of the array. Now we will display these elements, so we'll display a message unsorted array, as we know that these array elements are unsorted, so we'll print the message unsorted with /n. Alright, now we'll write the for loop int I equals 0 that runs from I0 to I8, because we want to print the array I less than equal to 8, I less than 8, I plus plus. Now here we will print the array arr I. So one by one all the elements will get printed, and we'll add the /t to add the horizontal space between each element. Alright, now for space we can write endl. Now we will write the logic for bubble sort. As we know, in bubble sort the swapping is done starting from the first two elements, and if the element on the left is greater than the element on the right, then the swapping is done. So we'll do that. We'll write a for loop which runs from I0 to 8, int I equals 0, I less than 8, I plus plus, and the second for loop would be int j equals I plus 1, j less than 8, j plus plus. Now I'll explain both of these loops, but before that let us just write the if condition for swapping. If arr I is less than arr j, oh, I write the opposite of that, which I have to write. Let's make it I. Yeah, if arr of j is less than arr of I, then we'll do the swap. So now I'll explain this part. Here when I is at 0, then j is at 0 plus 1, that is at index 1. So now comparison will take place between element at index 1 and element at index 0. If the right element, that is index 1 element, is smaller than the left element, that is index 0 element, then swapping will take place. And similarly, one by one, each element is compared with the next element, and it will proceed till the end of the array. So now here we will write the swapping logic. we will store the first variable into the temporary variable, and then we will store the second variable into array of I. Then we'll again store into array of j the value holded by the temporary variable. Alright, so this is how swapping is done. Now all we need to do is to just print the array elements, because we have to show the sorted elements of the array. So we'll first display a message sorted elements, right, and then we'll use /n as well. Now here again we will use the for loop, and which runs from I0 to I8, e less than 8, I++, and now we will print the elements of the array, of sorted array. Just to add the horizontal space, we can write /t, and now after that return 0. Let's save it and let's hope it will work. So as we can see, this is the unsorted array 12, 3, 1, 5, 18, 10, 7, 35, and this is our sorted elements of the array 1, 3, 5, 7, 10, 12, 18, 35. So as you can see, these elements are sorted, and using the /t we have added the space between each of these elements. Alright, now let's do another example. So now let's do an example of insertion sort. First of all, let's save it and let's name it as sort2.cpp. Now let's add the header files, #include iostream, then write the namespace standard, then we'll start with the main function int main. Now we'll write the variables like int I, int j, and num variable, then the temp variable, temporary variable, and we'll also initialize the array. Let's make it 30 size. Now we'll take the input from the user. So write enter the elements, enter the number of elements first of all. Alright, we'll take the input as num, and then we'll ask the user to enter the elements. Alright, now using for loop I equals to 0 till I less than num I++. We will take the input of the elements of the array one by one. So num is the size of the array, so one by one all the elements the user will enter all the elements. Alright, after that, now we'll write the code for insertion sort. Please keep in mind, in insertion sort we start by comparing the second element with the first element. If the second element is smaller than the first element, then we will swap it. After that, we will compare the third element with all the elements that are before it. Similarly, it goes for the fourth element and so on. we can see this figure for reference, and now we'll start doing the code. We'll start by writing the for loop which starts from 0 till num minus 1, I less than num I plus plus. Alright, after that we will store the array in the temporary variable. Once it's done, then we'll write ji minus 1. First of all, we have copied the elements of array to the temp variable. Then we have set j equals to I minus 1 because we have to compare it with the previous element. And alright, now we'll write the while loop. Okay, so temp is less than arr of j plus 1. No, only j. And for termination, j must be greater than 0. Alright, let's make them inside the brackets. Alright, now first of all let's write the code, then I'll explain the part. Array of j plus 1, array of j. We will move this element forward and then we'll write j minus 1, will decrement it. Then we have to insert the element in this place. Alright, I'll explain this part. In this part we have copied the elements of array to the temp variable first of all, and then we have set j equals to I minus 1 because we have to compare it with one previous element. And while in while loop we are checking if the value of element prior to array of j is more or less. If it is less, then we move the element in order to set it to the right position. Using array of j plus 1 equals to temp, we are actually inserting the element in a proper place or the right position. We are validating that j remains greater than equal to 0. So this is how it's done, and now we have to print the elements. So now we have to print the sorted element, so we'll write the message, we'll display the message sorted elements, and then using the for loop we'll display all the elements one by one. I plus plus arr, inside it will write I, and we'll add some space. Once it's done, then all is left is to write return 0. Return 0. Now let's save it. Once it is saved, then now let's check if it is running fine or not. As we can see, enter the number of elements in the array. Let's say there are 5 elements, right? 8, 1, 4, 9, 2. Alright, 8, 1, 4, 9, 2. So our output is wrong. Let's check where it is. I less than equal to. This is the problem. Let's save it and let's check it once more. 5. Now 8, 5, 7, 2, 6, 8, 2, 5, 6, 7. Alright, now I get it. Actually we are checking from the first element, so we have to start with the first index. Now let's save it and try one more time. 5, 9, 5, 8, 2, and let's say 12. 2, 5, 8, 9, 12. So finally our output is correct. Because of some logical mistakes, our output was getting wrong, but now we finally can see that 2, 5, 8, 9, 12, the elements of the array are finally sorted, and this is how you can do insertion sort. Now after this we'll do another example. Alright, now let's do an example of selection sort. Let's name it as sort3.cpp. So let's understand this selection sorting technique one more time. In this technique, the smallest element is fetched by comparing itself with the rest of the element and is sorted at the first position of the array. After the first element is positioned, the search for the second element begins from the rest of the array and is positioned at the second place. Similarly, all other elements are positioned like this, as we can see in the figure. Now let's do its practical implementation. So let's start by adding the header files. Hash include iostream. Then we'll write the using namespace standard. Now we'll start with the main function. Alright, so first of all we'll declare some variables like int I, int j, int num variable, then a variable p, and a temporary variable temp, and we also need a minimum variable. We'll name it min, and now we will declare the array. Let's make it of size 10, and yeah, now we will display a message saying that enter the number of elements. We'll write enter the number of elements. Alright, now we will take the input, see in num. Now we'll ask them to enter the elements. So we'll write /n, enter the elements. Alright, now again we will use /n. Once it's done, now we can take the input of the array. So we'll start with int I equals 0, I less than num, I plus plus, and now cin array arr index I. So yeah, now we can take the input from the user, and now we have to do the actual part, that is the selection sort. We have to sort the array using the selection sort technique. So let's start. We'll write a for loop int I equals 0, I less than num minus 1, I plus plus. Inside this loop we will store the value of the first element of the array. Min equals arr of I. We are storing the first element of array into this min variable. So here we are storing the value. Now we have to store the index. So the p variable which we have declared, and we are storing the index I to this p variable. Alright, after that we have to use another for loop where the actual comparisons begins. Now we will write j equals to I plus 1 and j less than num j plus plus. Now I'll explain you this for loop. In this for loop we are doing I plus 1 because here the comparison will take place and the comparison will occur with the preceding elements. So we have to do j equals to I plus 1. Now we have to do inside this for loop we'll use a if condition. So we'll write if minimum is greater than array of j, that is if any element is smaller than the minimum element, then that particular element will be set as minimum element. So we'll do that. We'll write min equals array of j, and we also have to change the index. So we'll assign the index of j to the p. Earlier we have assigned the index I to p, but if that particular element is smaller than the minimum element, then we also have to assign the index to p. Now all we need to do is to swap. So now let's do the swapping part as well. Alright. So first of all, the temporary variable temp, we will assign ARR of I. We have to swap ARR of I and ARR of P because the index J is assigned to P. And we all know how to do the swapping. Of I. Now we will put the value of ARR of P into ARR of I. Now the value at temp goes to ARR of P. So the swapping is done here, and now we have to just print the sorted array. So now let's first of all display a message saying that the sorted elements are, right, /n sorted elements are /n again. Now using for loop we will print all those elements equals 0, I less than n, I plus plus. Alright, now we will just print the array, and now in order to give some space we'll use the double quotes. Now it's done. Now return 0 will write. Now everything is done. Now let's check if it is working or not. It's done by our end, so let's save it and let's try to run. Enter the number of elements. Okay, so let's add 5. Now 5 elements are 8, 1, 5, 1, 5, 3, 7. 1, 3, 5, 7, 8. As you can see, these are the sorted elements and this is correct. So this is how we can do the selection sort. This is our logic behind the selection sort. You can try this example as well. Alright, now we'll do an example of quick sort. So first of all, let's create a new file and name it as sort4.cpp. Now as we know, in quick sort follows the divide and conquer algorithm. So let's have a look at it. As we know, in quick sort a pivot element is selected, like Here we have selected 6 as a pivot element, and then the elements which are smaller than 6 are put on the left side, and elements which are greater than 6 are shifted to the right side. And similarly, same thing is done with the partitions or the subarrays. And in the end, when we combine, we get a sorted array. So now, practical implementation. So first of all, we'll start by creating a main function, and before that we'll add the header files #include iostream and the namespace standard. Alright, now we'll start with the main function. Inside the main function, we will declare a variable num and another variable I, and declare an array ARR of size, let's say 10. Now we'll display a message saying that enter the number of elements. Enter the number of elements. Alright, now here it is. Now we will take the input from the user num. Now we'll display another message saying that enter the elements. And now we'll use for loop to take the input from the user. I equals 0, I less than num I plus plus. So inside this loop, cin and arri will take the input from the user. User enters all the digits or the elements. Now we will call a function quick. And we'll pass the arguments array and the starting index and the ending index. The starting index would be 0 and ending index would be num minus 1, that is size minus 1. So this is where we are calling the quick function, and after that we can display a message saying that after sorting the elements are. And now using for loop again, we can display the sorted array afterwards. We'll add some space. Yes, and we'll write return 0. So our main function is done. Now all we need to do is to make the quick function. Alright, so let's create this quick function. Quick, and its data type would be void quick, and we'll pass the arguments or the parameters are array and the starting index and the ending index. Start, int, end. So these are the parameters, and inside this quick function we'll write the if condition, that is if start of the index is less than end, that is if the array element is more than 1, then here we will find the point of division D, and then there would be recursive calls for the divided subarrays or the partitions. So now we will make the division point D, and now we will call the function divide, and we'll pass the parameters array and the starting index and the ending index to this function as well. So here D is the division point, and by calling this function we'll find this division point. After that we will do the recursive call for the left subarray and the right subarray. So let's do that. Quick array in starting index and ending index. But here ending index would be, as it is a subarray, as it is the left subarray, so the division point is the point of division. So the ending index for the left subarray would be d minus 1. And similarly, now again we'll call for the right subarray. Here the starting index would be d plus 1 and the ending index would be end. Let me explain this part again. The first recursive call would be from start to d minus 1, and the second recursive call is from d plus 1 to the end. So these are the two subarrays. This is the right subarray and this one is the left subarray. So d minus 1 is this element and d plus 1 is this element. Alright, now we'll make this divide function, and we have to make this divide function above the quick function, otherwise it will show an error. Or if you don't want to do that, then you can do the forward declaration, but I'll prefer doing this only. So int is the data type, divide is the name, and now int arr, as we have passed the starting index and the starting index and the ending index. Alright, now inside this divide function, first of all we will set a pivot element. So we'll do that arr. We usually select the last element as pivot element, or you can select the first element as well, or any random element. Now we'll create another variable int index and we'll assign it start index. Now this variable will keep the track of elements in the array, starting from all first element and all these elements. So now we'll use a for loop, and now we will do the comparison with the pivot element. So inside the for loop, int I equals start, because we'll start from the first element. So I equals start, I less than, and we will not use less than equal to, we'll use I less than n, because we don't want to include the pivot element. So that is why we'll use I less than end, and now I plus plus. Alright, now inside this for loop we will create if condition. Now in this condition, if the array of I is less than the pivot element, then we will shift it towards the left. Then we'll do the swapping. And arr I is less than pivot, then temporary variable temp, and we all know how to do the swapping, so we'll do that. arr I index. Please note that index is storing the start and pivot is storing the end, so keep in mind that. Now arr index, this temporary variable. Now we will increment this index plus plus, because this index plus plus will do the further comparison with pivot element. So if that particular element is smaller than the pivot element, then it will move to the left side, otherwise on the right side. Alright, now it's done. Now the only thing left is the positioning of the pivot element, and to do that, because we have to find the partitioning point, so we have to position the pivot element at its proper place. So for that we'll use the temporary variable again, and arr and index, then we'll swap it with index. So here we are done with the swapping. Now we have found the partitioning point, so we'll return the index. Now the pivot is at its proper position. Now all the elements on the left side of the pivot element are smaller than that, and all the elements on the right side of it are greater than that. Now let's try to save it and run it. I hope it works. There are some errors. Let's check. Alright, let's do it. And this one is extra. Alright, now let's save it and run it. Enter the number of elements. Let's say we have entered 5, not that place. 5 elements. 3, 1, 9, 5, 7. 1, 3, 5, 7, 9. So this is our sorted elements of the array, and we have done it using the quicksort method or the algorithm. And this is our code, and this is our logic behind the quicksort method. You can also practice this quicksort algorithm. It is one of the most efficient sorting algorithm. And we have done the examples of bubble sort, selection sort, insertion sort, and quicksort. You can practice them all.
Today's topic is pointers in C++. And in today's session, we will learn about what is a pointer, reference and dereference operator, then declaration and initialization of a pointer, then there is pointer arithmetic, and after that we'll go through pointers and functions, pointers and arrays, and at last we have arrays of pointers. So let's go to our first topic, that is, what is a pointer? A pointer can be defined as a variable that contains the address of another variable. It basically stores the memory address, which means it points to an address of a particular value. And like a regular variable, pointers have a data type also. Now coming to reference and dereference operators. Reference operator or address of operator is defined as that operator which is used to get the address of the variable. It can be easily obtained by preceding the name of the variable with an ampersand sign. Now, dereference operator. Dereference operator basically returns the content stored in the variable pointed by the specified pointer. For example, if we write *a, then it will return the value of variable pointed by a. Now, let's see how to declare and initialize a pointer. To declare a pointer, first of all, we will write the data type. After that, we will write the name of the variable with an asterisk sign. For example, int asterisk sign a, float asterisk b, char asterisk c. Suppose if we want to store the address into a pointer, then we will write int, that is the data type, then ptr, that is the name of the pointer, with an asterisk sign equals to a variable a with ampersand sign, which means ptr will contain the address of the variable a. Now, moving to a pointer arithmetic. C++ allows us to perform addition and subtraction operations on pointers. A pointer is basically an address, that is, it's a numeric value. Therefore, operations like addition, subtraction can easily be done on pointers. There are 4 types of arithmetic operations that can be used in pointers, that is, increment operator, decrement operator, addition, and subtraction. Each time a pointer is incremented by 1, it points to the memory location of the next element. But if the pointer is an integer pointer, its value on ptr++ would increment by 4 bytes because of the size of int data type. For example, assume an integer pointer with current value of 10. Now after the increment, its value would be 14 instead of 11 because int is of 4 bytes. Now let's learn about pointers and functions. Like a normal variable has an address, similarly every function has an address also. And we can easily access the function using its reference or address, only if we know the address of the function. Function pointers are similar to that of normal pointers. When pointers are passed to the function, the address of actual arguments in the calling function is copied into the formal arguments of the called function. And this is the syntax for a declaration of function pointer. Here int is the return type, and parentheses around function pointer tells the compiler that it is a pointer to function. And after this, they are argument lists. Now, let's discuss pointers and arrays. Arrays and pointers are very closely related to each other, and both of them are objects. When an array gets declared, the compiler assigns a continuous block of memory so that all the elements of an array can be stored in the memory. And C++ treats the name of the array as a pointer that contains the address of first element, which is known as base address. So basically, array name is the base address of the array. And if we have to assign the address of first element of array in a variable x, then instead of writing x equal to ampersand array of 0, we can simply write the name of the array only. Now, moving to the last topic, that is array of pointers. Like in array, we can store similar type of elements. It is same in case of array of pointers. But the only difference is, instead of storing the elements, the address of similar type of element is stored. In other words, it stores the pointers which point to the similar data type. And this is the syntax. First is data type, then name of array with an asterisk sign, then in the brackets it is the size of array. Now let's do some examples in our code editor, that is VS Code.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by SimpliLearn. Click on the link in the description to know more.
Here we will do one example of pointer to understand reference and dereference operator. We will print the values of variable and the address of that variable also, and it will give us an idea about reference and dereference operator. Let's start. First of all, we'll make a new file and name this file as pointer1.cpp. So first of all, we will import the header file #include iostream. Now we will include namespace standard. After that, we'll make int main. And now we will declare a variable val and assign it a value, let's say 105. Now we will declare a pointer variable ptr. Now we will store the address of the variable val into the pointer variable. So we will write ptr equals ampersand val. Now we'll display a message. Before printing val variable, we'll display a message saying value of val is. Now let's see what is the value of ptr. For that we will have to print ptr also, and we'll write value of ptr is. Now we will print the pointer variable ptr also. Although the value of val and ptr would be same, but in order to check, we will print that also. So we'll write cout value of specific ptr is. Now as we have printed variable val, ptr and asterisk ptr, so now let's check all these values. Let's first of all we'll write return 0. Now let's check all these values. Here we can see value of variable val is 105 and the value of ptr is this. This is actually the address, and the value of pointer variable ptr is 105. As we know that the value of val and the pointer variable is same because we have assigned this value, the address of variable val, to ptr, and then the dereference operator, as we know, returns the actual content of the variable. So that is why the value of variable val gets printed when we print the pointer variable ptr, and the address over here is the address of the val variable which we are assigning to the ptr. So that is why this address is getting printed. Now we'll do another example. Let's name it pointer2.cpp. Now we'll include the header files. Hash include iostream. After that, using namespace standard. So here we have an example of arithmetic operations in C++. So first of all, we'll write int main. Now here we will take 4 variables and 2 pointers. So let's do it. Int num1, num2, int sum equals 0, and int sub equals 0. We'll initialize it with 0. Now we will declare the pointers ptr1, ptr2. So let's take input of the required variables num1 and num2, and after that we'll do some arithmetic operations on them. So let's just write. First we'll display a message. Enter 2 numbers. Enter 2 numbers. Now we'll take the input. After this, we will store the address of num1 and num2 into ptr1 and ptr2 respectively. So let's do it. ptr1 ampersand num1, ptr2 ampersand num2. Now we will increment pointer ptr1 and ptr2. We'll do in a bracket, and we'll use dereference operator also. ptr1 plus plus dereference operator ptr2 plus plus. Here we are using dereference operator because we want to increment the value only. And as we can see, we have used increment operator. So by incrementing ptr1 and ptr2, the values of num1 and num2 will increment, and after that we will print those values. So let's do it. Before printing, we'll just print a message after increment. Now we will print ptr1 and line. Now ptr2. Now we will do the sum of these incremented values. So we will write sum equals dereference operator ptr1 plus dereference operator ptr2. Now we will simply print it. We'll write addition and we'll print some variable which we have already initialized as 0 earlier, and we'll write endline. So this will give us the sum of the incremented values of num1 and num2. Now let's talk about decrementing the value of pointers using decrement operator. Here by using this operator, the value of the ptr1 and ptr2 gets decremented. So let's start. We'll write decrement ptr1 minus minus. That is the decrement operator. Now ptr2 minus minus. Now we will write after decrement the values of ptr1 and ptr2. So we'll display a message saying after decrement now we will print ptr1 and ptr2. This will display the values of ptr1 and ptr2 after decrement. And at last we will find the subtraction of 2. So we'll write sub decrement operator ptr1 minus decrement operator ptr2 and cout will display first subtraction. We'll write subtraction, then we'll write the variable sub. Let's see how it. Before that, I think we forgot to mention the dereference operator while printing. We have to mention this because we want to print the values. Dereference operator. And let's put some space over here. Now let's try. Enter two numbers. So let's say we'll enter 4 and 5. As we can see, we have entered 4 and 5. After increment, it becomes 5 and 6. And on addition, it becomes 11. After decrement, it becomes 4 and 5 again. Then 4 minus 5, that is equal to minus 1. So this is the right answer. And this is how it's done. This was the basic example of arithmetic operations in pointers. Now let's do another example. Name this file as pointer3.cpp. Now we will include the header files hash include iostream using namespace standard. Now we'll write int main. Now we will do an example of pointer and arrays in which all we have to do is to print an array with the help of pointers. So let's start. First of all, we'll declare a pointer. Now we'll declare an array named RRAY. And let's add some elements inside it. 5, 17, 20, 7, 9, 4, 6. I think these are 7 elements. Now we will assign array ARR to pointer PTR. So we'll write PTR equals ARR. After that, we'll run a loop from I equal to 0 to I less than 7 because we want to iterate array elements. So let's write for loop int I equals 0, I less than 7, I plus plus. Now we'll display using dereference operator with pointer because we want to display the values, that is why we have used dereference operator. Now we'll do PTR plus plus. We have used PTR plus plus because we want the pointer to move to the next position after each iteration, and endl will help to print the output in the next line after each iteration. So after this we'll write return 0 and let's try to run it. I think there is some error. Yeah, namespace. Now let's again try to run it. Instead of array we have used ARR. Hope it works now. Here it is. 27946. 5, 17, 27, 946. So these are our array elements which we want to print. So this is how we can print the array elements with the help of pointer. So these were some basic examples of pointers in C++.
In this session, we will learn about this pointer in C++. So let's go ahead and have a look at what we'll be covering today. So in this session, we will cover topics like what is this pointer. Then we will have a look at the syntax of this pointer. Then we will understand the working of this pointer, and after that we will learn how to access the executing object using this keyword. And we will also learn about the features of this pointer. But before we begin, make sure to subscribe to our channel and hit the bell icon to never miss an update. So our first topic is, what is this pointer? In C++, this is a keyword that is used to represent an object that invokes the member functions. It automatically points to the object for which the object is being called. Or, in other words, this keyword points to the current instance or object of the class. For example, let us suppose we have a local variable of same name as that of the data member, and we want to assign the value of a local variable to the data member, but having the same name would create a problem. So in this type of case, we use this pointer. The this keyword tells the compiler that we are referring to object's data members. Now let's learn about the syntax of this pointer. The syntax for referring class variable or instance variable would be this keyword, then arrow operator with class variable equal to local variable value. And the syntax for referring to current object of class would be this with asterisk sign or dereference operator sign. Now let's understand working of this pointer. The this keyword represents the address of current instance of the class. The this pointer acts as an implicit parameter to all the member functions. Now implicit parameters are similar to normal parameters. The only difference is these parameters are passed silently to the functions. That is, it is passed as a hidden argument and is automatically passed to the member function when it is called. Now let's learn how to access the executing object. As we can see in the example, we have created an object obj of class O, and with the help of this object we have called this function display, in which we are printing the address of the object, and we are also printing this pointer, and this is the executing object. So by printing this, we will get the address of object in the memory. Along with this, we can also access the data members using this keyword. Alright, now let's move to features of this pointer. The first feature would be to distinguish the data members from local variables, which means it helps in making the class members more readable by differentiating the members of the class and the parameters which have the same name. This keyword helps in differentiating between the class variable and the parameters. As we can see in the example, we are assigning the var variable, which is a parameter, to the class member var, and this can only be done with the help of this pointer. Now let's move to the next feature, that is method chaining in C++. Method chaining in C++ is a very useful feature of this pointer. It helps to chain methods together for ease and cleaner code. In this, each method returns an object and allows the code to be chained together into a single statement. It helps in invoking multiple methods that are chained together. As we can see in the example, set method, replace method, and inc method are chained together in a single statement, and arguments are also passed.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by SimpliLearn. Click on the link in the description to know more.
So now let's go ahead and do some examples of this pointer in our code editor, that is VS Code. Alright, so here we will do an example of this pointer in which we will show that how this pointer differentiates between the class member and the parameters having the same name. So let's go ahead and first of all let's create a new file and let's name it this one.cpp. Alright, now we can write the header files #include iostream. Now we'll write the namespace standard. Now we'll start with the main function. We'll write int main. Inside int main, first of all, we will write the class name and then the object of that class, let's say obj. Now let's write return 0 first of all, and now we can make some calls with this object, but before that let's create class. So alright, now we have to create a class which has the name A. As we know, the class name is A, we have already defined, and the name of the object is obj. So let's create class A, and inside that class we will, inside the private scope, we will declare some variables. Let's say int x, y, and z. So these three are the variables. Now I'm sorry, spelling is wrong, int z. So these three are the variables. Now inside the public scope we will create a function. Let's say the name of the function is set. So data type is void, name of the function is set, and from the main function we will call this set function. So all we need to do is we'll write the name of the object obj dot operators set, which is the name of the function, and we will pass the arguments, let's say 20, 54 and 65. These are random numbers. Now here we will write int x, int y, int z. As we can see, the parameters and the class members have the same name. So variables are of same name. So for that we know that we have to write this pointer. So we will write this x. So here this x is the parameter 1 and this x is the class variable. So this pointer differentiates between both of them. As the name is same, so this will help in differentiating. We'll do the same for y, and we'll do same for x. This arrow operator z equals to z. So here we are assigning the values to these class members. Now after that we will display these values. So let's create another function. Let's say the name of the function is void print. Alright, so inside this function we will simply display these variables. So we'll write x value is the small one x value is the variable x, and after that we will write and l. Right, y value is y and l. We'll do same for z. We can copy it and just paste it. It will save some time. Alright, as we have displayed or printed all of these three variables, so as the class ends, so we need to add the semicolon in the end. Now this print function, we need to call this one. So with obj object we will call this print function. Alright, so after calling this we have already added return 0. So let's save this one and try to run it. Alright, let's check. Here it is. X value is 20, y value is 54 and z value is 65. So arrow operator helped us in differentiating between the class members and the parameters. What if we don't use this? Let's have a look at that as well. If we do not use this pointer, then let's save it and let's try to run this. Let's check the output. As we can see, x value is 0, y value is 0, z value is 0. It is not correct. So this one is right and this is our output, correct output. Now let's do another example. So here we will do an example and see that this pointer can be used for calling the member function as well. So we'll do an example regarding that. So first of all, let's name this 2.cpp. Let's save it, and we'll start with hash include IOStream. Now the namespace standard. We'll start with int main. Inside int main we will name the class and create the object obj. The class name is king and the object name is obj. So from here we will call a function. Let's say obj dot, let's say the name of the function is text. Here we are calling, and let's say return 0 after this. Now we have to create this class. So let's create this class king, and inside this class king, inside the public scope, we will declare the functions. First of all, we'll declare a function call, and now we will define a function that is text. So inside this text function, all we need to do is to print a message and call another function. So first of all, we will print a text or a message. Let's say hello brother. So after that we'll write endl. Now we will call another, not cout. We will call this function call, which we have declared and not defined yet. So we will write this arrow operator cal call. This is how you can call using this pointer, and here we are calling this call function. So we'll close the class using semicolon, and now inside the class scope, let's say void king scope resolution operator. This means that this function is of class king. So now we will print whatsoever we want. Let's say a is, will display a text. Let's say a, and that's it. Then we'll do the same for B and C. Here we will print B, and now we will print C. Alright, now all we need to do, and everything is done. Yeah, because we have created this function outside, so we don't have to use this semicolon. Now we can save this and we can try to run this. Here we can see hello brother and ABC. So this is what we want to print. Here we can see we have used this pointer to call this call function, and after printing this hello brother, A, B and C is getting printed, so this means this is the correct output. Now let's do another example. Let's make a new file and save this one. Let's name it this 3.cpp. Alright, so here now we will do an example of method chaining. As we know, we use method chaining when we want to return the reference of the object, and method chaining helps us in writing a clean code as it chains up the calling together into a single statement. So let's start. First of all, we'll include the header file hash include IOStream. Now we'll write the namespace standard. Now we'll write the main function. By mistake we have Alright. Now inside the main function, first of all we'll write the name of the class, that is test, and we'll create the object. The name of the object would be n1. Now we will chain up the calls. Let's say the name of the object n1 and the name of the function, let's say, is assign, and we are passing 100. And now we'll chain up display function with it. So this is method chaining. Now we'll write return 0, and now we'll start with the class. So class name is test, and inside the class we'll declare a variable, let's say num, and now under public scope we will write the function, and we'll not define the function in a usual way. We'll write the data type. First of all, let's say test is the data type, address of operator, assign, which is the name of the function, and argument would be num. The parameter would be num, and inside this function we'll use this arrow operator, and now we will assign the value of parameter num to the class variable. After that we can return reference to the object. We'll use the dereference operator and this pointer. Now we'll make another function, that is display, and inside this display function we'll print a message, and we'll print the variable, that is num. So first of all we'll print the message saying that the value of num is alright. After the class we'll put a semicolon, and we'll try to run this one after saving it. So as we can see, the value of num is 100. So let's do some modifications in that. Let's say we want to add 1000, so it will get added, but we need to save it first. Now we'll try to run. As you can see, the value of num is now 1100. So these are chain function calls, and when the reference is returned, this reference is returned, then this reference can be used to chain the function calls from a single object, that is n1 in this case. So this is the data type and this is the address of operator. When we are doing the method chain, we must do it like this, and then we will return the reference to the object. So these were some examples of this pointer in C++. You can try some more examples if you want to learn this topic in a much better way. In this video, we will learn about references in C++. So let's go ahead and have a look at what we'll be covering today. So we will learn what are references in C++, then the creation of references. After that, we will learn about reference in the function and returning the reference from the function. Next, we will have a look at the applications of references and understand the difference between reference and pointer. But before we begin, make sure to subscribe to our channel and press the bell icon to never miss an update. So first is, what are references in C++? A reference can be defined as an alternative name of the variable. As the name suggests, it is used to refer to an existing variable. It is basically used to store the reference of the variable and is stored using an ampersand sign. Although the reference and address are the same thing, but their context is different. When we are talking about reference variable, then we will call it reference, rather than address. The variable can either be accessed with the help of variable name or by the reference name. So as we have understood about references in C++, so now let's learn how to create reference in C++. Let's suppose we have a variable named data, and we know how to declare a variable. First its data type, then the variable name, and then we will assign the value to the variable. Here int is the data type, data is the variable name, and 10 is the value that is assigned to the variable. If we want to declare a reference variable for the variable data, then it would be like this. First is the data type with ampersand sign, then the name of the reference variable equals to the variable name of which we are storing the reference of. As you can see, int ampersand ref, which is the name of the reference variable, equals to data, which is the name of the variable. So we can say ref is the reference variable for the data variable, and it can be used instead of the variable name. Now coming to reference in the function. We can pass the reference to the function as a parameter. It is similar to passing the pointers to the function, but it is safer. While passing the reference to the function, the changes made inside the function will also be reflected outside, because after passing the reference to the function, the passed reference will access the actual argument. So the changes that are done to the parameter inside the function will affect the arguments. In addition, it is safer and provides a cleaner code. To pass the value as reference, all we need to do is to change the function parameter as reference type, as we can see in the calculation function int ampersand a. Now let's learn about returning the reference in C++. Similar to pointers, references can also be returned. While returning the reference, an implicit pointer is also returned. In return by reference, no local variable is returned and no constant is returned. Only the global variable is returned. In return by reference, function calling is done on the left hand side of the assignment operator. As you can see in the example, n is returned from the function, but it is not the value that we are returning, but the address of the variable. When this variable is returned, then the value 15 is assigned to it, which is then printed as we can see in the example. Now coming to applications of references in C++. So first is, references helps in modifying or changing the values inside the function without actually passing the actual arguments, because we can easily pass the reference instead of variable, and if we pass the reference to the function, then also it can modify or change the values. Second is, references helps with operator overloading, because unlike pointers, they work with references and values rather than pointer variables. Third is, references helps with writing less error-prone code, and by replacing values with references while calling avoids the unnecessary copy of data. So these were some applications of references in C++. Now let's understand the difference between reference and pointer. The reference can be defined as an alias of the variable. Here the word alias means additional name, or we can say also known for the name. On the other hand, a pointer is used to store the memory address of the variable. Reference cannot have a null value, whereas pointers can have a null value. References cannot be reassigned to other values, whereas pointers can be reassigned to other values. It returns the reference of the variable. On the other hand, pointer returns the value located at the address of the variable. Reference can be initialized during its creation only. It cannot be reinitialized, whereas pointer can be initialized as many times as required. So these were some differences between reference and pointer. Now let's go ahead and do some examples of reference in C++ in our code editor, that is VS Code. Alright, so here we will do an example of return by reference in C++. We all know how to return a value from a function. So now we will understand how can we return a reference from the function. Alright, so let's start. First of all, create a new folder and let's save it and name it as ref1.cpp. Now we will save it. Alright, so first of all we'll include the header files and then we'll start with the main function. Hash include iostream, then the namespace standard. Now let's start with the main function. Inside the main function, first of all, like normally we'll do for the functions, we'll call, let's name the function as club. So this is how we normally call a function, and after that we create a function like this, like int club, and then this is how normal calling works. But in this case we want this function to return the reference, and for that we have to use the ampersand sign. So we have used this ampersand sign, and this is the syntax: int, which is the data type, then the ampersand sign, then the name of the function, and if we want to pass any arguments then we can do that. And keep in mind that inside this function we cannot return any local variable or any constant. Like we cannot create a variable inside this function, assign it some value and then return it. We can't do that, and we can only return the global variable. Let me show you that we cannot return this, return 8, as this is a constant, and we can't do like this, like int p equals to 9 and then we will return p. We can't do like this as well. All we need to do is to create a global variable and then we will return. Alright, so let's create a global variable. Let's say the global variable is n, and so we'll return n. Now if we want to assign some value to this global variable, we have to call this club function, and we have to make this calling on the left hand side of the assignment operator like this. And now we have to assign the value, like let's say the value is 75. So here we are assigning the value and calling this reference operator. We are assigning the value to this global variable, this n global variable, and in this part we are actually assigning this 75 value to this global variable n. Now we can print this n variable, which is global, and check if its value is 75 or not. Alright, so let's save it and let's try to run this. As you can see, 75. So this is an example of return by reference in C++. Now let's move on to another example. Alright, now we know a reference cannot be reassigned. That also means a single reference cannot refer to two different values. But two different references can have a single value, or in other words, a value can have two different references. So in this example, we'll show how a value can have two different references. So let's start doing this example. First of all, we'll include the header files. Hash include iostream. Now the namespace standard. Alright. Now inside the main function, we will create a variable and two different references. The variable is num and we will assign it a value, let's say 70, and we will create two different references, int num1 n1, and we will assign it to num and n2, which is also assigning to the same variable. So there are two references n1 and n2 which are referring to the same variable num. So now we will print this variable num and both of these reference variables, that is n1 and n2, to check if they are pointing to the same value. So let's do this. We will write cout value of num is alright. Now again, value of reference n1 is n1 and l. Similarly, value of reference n2 is n2 and l. Alright, so we have printed all of these variables and references, and now return 0, and let's check if they are running fine or not. As you can see, value of num is 70, value of reference n1 is 70, and n2 reference is 70. So we can say all of these references and variables are pointing to the same value, and the value of num can also be accessed by this reference variable n1 and n2. Alright, now let's do another example. Let's name it ref2.cpp. So here we will do an example of references in C++ in which we will pass the reference into the function to swap the actual values. Basically, we don't pass the actual arguments, we only pass the references and swap the values. So let's start. So let's include the header files. Now we will create the main function, and inside the main function we will declare two variables and assign the values. Int y 17, let's say. Now we'll print, first of all we'll print before swapping, right? Alright, so now we will call the function swap. We will create a function swap afterwards, and we'll pass not the values but the references, and then we can similarly copy this one and just paste it again, and we'll do that after swapping. Here we have to do before swapping, right? So first of all we'll print the value of x and y before swapping, then we will print the values of x and y after swapping. So now we have to create the definition or write the definition of swap function. So let's write void swap, and do remember that here we are passing the references, not the values, so we have to write like this: int ampersand n1. This is how, when we are passing the values, we have to write like this, and int ampersand n2. Here this n1 is referring to x and this n2 is referring to y. And inside this swap function we'll simply swap, as we know how to swap. Int temp equals n1, then we'll do n1 equals n2. We all know how to swap. Here we haven't passed the values, actually we have passed the reference, and using those references we are swapping the values. So now let's try to run this, save it, and let's run this. As you can see, before swapping x value is 12 and y value was 17, after swapping 17 and 12. So as we can see clearly that the value is swapped. So we can say using the references, or by passing the references to a function, we can actually swap the values. So this also proves that references can access the values. So these were some examples of references in C++. References in C++ is a very simple topic, and there are very limited examples on this topic. And if you find some more examples, please do try them.
And that brings us to the end of today's session, guys. I hope you understood all the topics and concepts of C++ that were covered in today's session. Thank you for watching the video, guys. I hope you found this tutorial informative and helpful. If you did, make sure to leave us a like and share it with your friends and colleagues. And if you have any further queries regarding any of the topics covered in today's session, feel free to let us know in the comment section below, and our team of experts will be more than happy to help resolve all your queries at the earliest. Stay tuned to the part 2 of this training program series on C++, wherein we'll be covering some more new topics. Until next time, stay safe and keep coding.